So welcome to this summer school's toughest workshop. Buckle up, this won't be easy, but we have a great team that will be able to support you. During this process, I present you Valdis Saulespurēns, my colleague at the National Library of Latvia. He will tell more about himself. But we have also 3 assistants, a very powerful team of assistants. Haralds, Melissa, and Zlata. Wave hands, yes. And I'm so sorry that yesterday we weren't clear enough that there is always support assistance in the audience. If you need help, you just give some sign about that, like shout out or wave your hand. Because this is really important for us that you do not get stuck. And this workshop, it gives you so many important components of being a digital humanist. Well, first of all, working with Google Colab. Secondly, working with APIs, understanding what it really is working with APIs, understanding better in what ways we can use large language models except from just talking to chatbot, and understanding how we can process a lot of data by using large language models, not just a couple of files. And do not worry if you will not understand every detail of what Valdis is saying to you, but if it's your first time, it will be so valuable to you just to understand that these things exist. Do not panic, and next time you will be even more wise about all these things. And now I give floor to Valdis.
Right, so thank you, Anna. I will be sitting mostly here and showing you some things. So thank you for my assistance. So the first question of the day is, did everybody get my email last evening? So did anybody not get an email? That's the question. Is raise your hand if you did not get an email or you some reason. So there's one person. That's great, because actually I was prepared for this. So there's a reason. And Harald will give you a link. Two people? Okay, so you each get a personalized website with your own private key. I was imagining that I checked that everybody who was on my list got the email, right? But it's possible. Yes, sure. Right. So these are worth $1 each, these keys, right? So, guard them with your life. But and they expire in about a week. So again, so the idea is, I'll show you one of them. Again, this is for those who are, basically you go to the web page and you will see the key. You can copy, paste it into whatever your local computer and for the session we are working. Because again, one of the core ideas when working with the API, you need some sort of permission, because we are using third-party providers who are generally paid. Of course, even if you are using your local university or library provider, it's possible. You will still need some sort of authorization, authentication, right? So, and one of the key takeaways from today's lecture is that you really need to be careful with these keys, especially if they are open-ended, meaning they have no limit. I'm sure you heard the stories of a graduate student who opens an Amazon account and next morning he wakes up to $10,000 bill, basically, because his notebook was running overnight and maybe he used some LLM assistant, ChatGPT or some other assistants, and he didn't really pay attention, and the model did too much, basically. His notebook did too much, and Amazon is very happy to take your money. Right, so that's one of the issues. But luckily, the good news is it's changing. We'll talk about this more, most of these providers of these services, they are starting to put limits, which is really important. I think that you cannot, if you make a simple, innocent mistake, you are not gonna break the bank, basically. Right, so again, so these are, they have some value, but it's not the end of the world if you lose it, right, or if you send it to your friend, right? So, okay, but they are, of course, for private use, for your own workshop, so for this workshop. So, okay, so everybody has the keys, either through email or through the website, and now we proceed to the actual materials. Again, all the materials are publicly available at this address, right? It's also available in the email I sent you, right? So, and we will be using Google Colab. So I assume most of you, the idea was for pre-workshop, for those who have very little experience, that you did the workshop session 0, at least skipped over it, right? This one here, right? So how you open it, right? You have the site, and I opened a new window, right? So open a new window. So I assume you went through, at least some of you. Raise your hands who did it. Yes, very good, excellent. Right. So again, if you have already experience, it was not necessary, but at least to get the idea what we are doing. Because the core idea of notebooks is, of course, to combine discourse, narration, textual, basically writing, with actual computation, code, right? So, and there are 3 ways of using notebooks. Basically, there's a passive, completely passive way, which is completely fine sometimes. Use it as a notebook, as a book, as a journal article. Just read what's been done, but don't do anything yourself, right? It's possible, do that, right? It's also completely fine sometimes. And then there's two more interactive ways. The second way, which I hope most of you will do today, is to actually run some code. And you'll see it's not so easy. It's not so hard. It's not so hard. It's easy. And actually run the computational cells, because there are 2 types of cells, the code and text. That's a core concept in notebooks, right? And we will do some computation, and the computation can be done against your local computer. But today we are working through the Google Compute infrastructure, the Google Colab Research Google.com, right? Which has been running for almost 10 years, keeps getting updated, getting better and better. And it's very convenient, right? Again, as long as you are on the same page as Google, basically, right? So if you have Google account, very good option. Again, for our real work, we usually work on local machines, meaning that job gets done at the local machine. Right? Maybe some of you also have some experience doing that locally, right? Who runs notebooks locally? Maybe anyone? Some of you, right? Yeah, of course. Yes, very good. So that's, of course, the next step. We are not going to go do any technical assistance with local running, because we are basically running this Google notebook, right? And I mentioned in materials, if you want changes to your notebook, what you will do, if you make some changes, right? Textual changes, either to code or to the text, to copy to drive, meaning you have your own notebook, basically, right? If you press copy to drive, it will be saved in your Google Drive somewhere. I think it's under Colab subfolder, I believe, and you can then inspect later. There are other ways of doing it. You can also download it. There are other ways of persisting this notebook to your own. But otherwise, if you don't do nothing, the work you do today, it will not persist, because it comes from this repository, this code repository, which I created for this workshop, and obviously you cannot push changes back, right? So if you want to save the changes, use copy to drive 1 time. Okay, but this is session 0. You already did this, or most of you. But we will go to session 1, right? That's our main session today, our first session, right? So workshop session 1. This is 1. Let's see what we have. And again, I added some pictures also, right? So the idea is, yes, Harald's asking.
Maybe we have to check that everybody
is going to
download the Google Colab. I think it's add. I don't know something. That everybody has a Google Colab running on your computer.
Harald, I believe if they have the links, they don't need the add-on.
Yeah, but still, anybody not having it.
Yeah, because yeah. So yeah. Yeah, exactly. This would be a good. Harald has a great point. So if you have, this will be before we proceed, would be to make sure everybody actually is on the same page, literally, right? We are on this address, right? Everybody should be on the same address at the moment, right? And again, if you will want to persist, you can do copy to drive later on. But for now, everybody should have access to this address. So your assistants can help you if you're not some problem. Because again, all that is required is your Gmail account and a connection to internet, and that's it. And of course, a browser, update browser. So the idea, of course, is I'm going to keep talking while assistants are helping. Because again, I am a lecturer at Riga Technical University, so I like to talk a lot, right? So idea is that we are agnostic to what device we use. I mean, technically, if your smartwatch supports a browser, you could open this Colab on your smartwatch, right? And of course, the tablet, I mean, it's very convenient, right? Again, but the downside, of course, is that this goes through the Google computing infrastructure. I believe this, we'll see these data processing centers are based, I believe, in Ireland or maybe Portugal, right? But not so crucial, of course, here. But that we are not actually, the actual work gets done somewhere else, right? This is so-called cloud computing for a good reason, right? Someone else's computer. Now, so are we all on the same page? Everybody has this, right? Okay, great. And you see this picture, right? Right. And again, the thing is, this, when there's like 60 or 70 of us, and we are all from the same Wi-Fi, right? We're all hitting Google servers. Sometimes it might be not completely not your fault. It might be Google's fault, right? Google is human too, right? So and so they make mistakes too, and their server infrastructure also can sometimes fail, right? So sometimes things get sluggish. And again, so yeah. But our goal today is to, well, at least first session is to learn to make this LLM API call. We'll talk about these terms. And then, so I guess I should proceed, right? So yeah, so there's this little section here, right? I don't have too many of these, but it's kind of, I think it's like kind of nice idea that these notebooks you have, when you are creating them, you can actually create these sort of what you call collapsible drop downs, right? And you can see a little bit more about us, about me, Harald, Zlata, and Melissa, right? Or BIOS, right? So yeah, again, I come from computing background, but I have a lot of fun teaching programming to digital humanities students actually at the university. So I think my best students actually come from digital humanities, right? Every year, Python, web development, and other courses. I don't know, maybe some of you have taken some course. And now Viesturs has taken courses with me, right? So, all right. Now, so you can read that afterwards, right? So our idea is to learn how to make a call. So again, LLM, right? So LLM, large language model. Again, that's a generic term. So the question, I guess, a couple of years ago when I was asking who is using LLMs, the question is now, is there anybody here who has never used LLM? I mean, I'd be amazed to find one person, two. Okay, it's not that I don't believe you, but the thing is, even if you don't use ChatGPT, if you don't use Claude, you don't use Gemini, or don't use Copilot, I imagine you probably have used LLM in some way without even being almost forced to. I mean, not necessarily a good thing. Like if you go to some website, they have all these chatbots, right? They're all running LLMs now these days. So if you're a very principled person, if you avoid all chatbots, good for you, right? But it's getting harder and harder every day, right? So I mean, I respect that actually, right? But the thing is, of course, LLMs, large language models, are basically everywhere. And again, it's not always a positive thing. There are lots of minuses to this. All right. So people or companies, organizations sometimes put LLM-based solutions where they may not be needed. Sometimes a simple, old rules-based approach might be completely appropriate, right? So, but today we will talk about what we can do with LLMs when we take control instead of letting somebody else. Because one of the issues, again, most of you have used something like ChatGPT or Gemini or Copilot or Claude or other, maybe Mistral, right? Maybe some other, again, maybe Kimi, maybe, I don't know, some other providers, DeepSeek, right? But when you're using a web interface, right, like ChatGPT, you don't have full control what's happening, actually. When you are sending your prompt, Latvian uzvedne, right? So there are other stuff happening. It's of course essential. LLM is already a black box, but there's other things that these providers provide, these prompts, extra system prompts, which basically, well, change some things. Maybe you don't necessarily want, if you're doing some analysis for digital humanities, right? And you want to analyze some documents using, I don't know, Gemini Notebook or ChatGPT or something else. And well, you don't have a full picture, right? There are some distortions, which again, already not counting with stochastic, somewhat, probabilistic nature of LLMs, which in self, right, as we all know, right, large language models are probabilistic in their nature, right? If you run prompt 10 times, right, you will get slightly different answers unless you set temperature to 0, right? But you will get slightly different answers. You can play around with this, right? It's always, there's some slight differences, unless your query is really basic, yes, no, of course. Even then, you might get 9 yes and 1 no, and then you're sure, right? So it happens. Right, so we'll talk about it. So our idea is to actually control, to create a handcrafted LLM query to some provider, right? And again, the idea is to understand that we can do this without being provider agnostic, right? So we control the narrative, basically. We don't say, okay, we have to use OpenAI, we have to use Claude or Gemini. We can use whatever we want, basically, best to our needs, our organizational needs. And we can evaluate, all right? And we can also, even counting with this probabilistic nature of LLMs, we can still provide some scientific backing, some replicability. That's also part of the reason notebooks exist. Notebooks are great because they provide you with a way of adding narrative, context, adding the text, the documentation, so what you are doing, why you are doing, crucially, why you are doing, right? So today's first session, we will try to make just a simple one call. That will be success. I'll only call this a success then. But then we'll, of course, time allowing, we'll look at some extra intermediate things we can do with our responses. On the second session after the lunch break, we will do batch processing, doing this in multiple times, because that's the idea. This actually goes back to programming and coding in general. If you can do something with one document, one item, you can do it with 10 or 100 or 1,000. So for whom this session, this workshop can be useful? If you are doing work with more than 10 documents, 20, 30, 100,000 documents you have to analyze, then this workshop should be useful. If you're only doing with 1 or 2 documents, then probably you can just get by with your own analysis. And of course, you can use your LLM methods, just, single shot, basically, methods. So, yeah. So how to use it, right? Again, I keep repeating because, again, the notebooks, again, might be new to some of you, right? That we have sound. So now everything's good. So code and text, right? So there might be some confusing sometimes that Google Colab calls this text, but in general term is called Markdown, right? So the question might be also, you already did some, so you have had some exposition to Markdown, at least from the first notebook, right? From the Zero notebook, and maybe before, right? Because Markdown, what is Markdown? It's a way of adding simple structure, right? Using a couple of extra symbols to your text, right? And again, it's extremely popular these days, right? And again, if I click up here, you can see what it looks like, right? This is Markdown. Left side is Markdown. Right side is so-called rendering, what we see, right? So you can see that the actual writing, again, once you get used to it, it takes, again, I've been using Markdown for like about maybe 10 years, but it's, there's not much syntax. You need to know, okay, bold is 2 stars, right? You don't need to learn HTML, for example, right? If you know HTML, that's good, but you don't need to know it. You need to know how to put 2 hashes. That's second level heading, right? Subheading, basically, right? So not, third level subheading. So I think very easy. I'm going to close it here, by the way, close Markdown editor, right? Yeah, so if I click it, you can see how the text or Markdown is done, actually, right? So one of the beauties of this is, again, if you have a publicly accessible notebook, like this one, right? Anybody in the world, right, can access it and see what's happening, basically, right? So, again, you can write, your narrative, it consists of all of your knowledge for that particular subject. So, and we will encounter the code cells, not just yet, right? But code cells are generally Python. And again, so how many people actually have used Python before this workshop? Maybe half, right? I saw that from, it's about half, right? So yeah, so again, sometimes the old way of using Python, how I used it like 20 years ago, was, of course, you write code on a text editor as a script or a program, right? And essentially, this is the same thing, except we put them inside the notebook, right? There are some couple differences, crucial differences, but again, it's not so much different actually underneath, right? And again, there's no need to understand everything. We live in a world of abstractions, of complexity. We don't need to know exactly how electricity works, right? When we flip a switch, that's one of my opening lessons, right? But there's a lot of happening there, up down to atomic physical level, right? So same thing with computers. I mean, it's been ages since you could understand everything that happens when I press mouse, right? There's many things happening, right? There's about 6, 7, 8 levels of abstraction underneath, right? Hidden of complexity, right? What's happening, but it works, right? So you need to understand, of course, your intermediate bubble, so to say, what's happening there, right? So you don't need to memorize everything, just the crucial concepts. And then you can also show you some tools how to make sense if you make some mistakes. And again, do not have to worry. You cannot really break anything. I mean, what's the worst going to happen, right? Nothing much. I mean, you could basically use up your API key in one query. I mean, then I'll give you another one, maybe, right? So, but yeah. So one thing you should remember, of course, is that text stays in the notebook, right? If you copy to drive, right, your change will stay, but the data leaves when you shut down the notebook. If you go away for a while. Right. So again, now we go to the big picture. What's happening when we do LLMs? Most of you already done it some way, right? Large language models are good, and there are more things happening every day, right? So summarization, right? In terms, fantastic, right? You can summarize the argument. It's again. A large modern, even models from last year or 2 years ago already are quite good. Second task, named entity recognition, right? Extract people, place, organizations. Again, we still have rules-based tools, but LLMs can do it as well, and also they can, it, right? Let's not I can't say the word, but you can, let's not provide human qualities to LLMs, right? But we can extract named entities, right? Again, it's task some of you have done already, right? Sentiment, again, 10 years ago, this was again rule-based. Didn't work so well, right? Now, LLMs can detect sarcasm, stance, tone. Excellent, right? It used to be, okay, they'll never detect sarcasm. Yeah, right. But they do, right? So now, classification. In essence, of course, large language models themselves are classification machines, basically, black boxes, right? But we can decide. This is one of the things we do at the library quite a bit. We have a document, whether it's mostly about music, maybe a little bit. You can estimate the degree, right? Agriculture, you can do, of course, this relevance and classification, either yes, no, binary. Is it about music or not? Or you can do it also about wide variety of subjects, multi-level classification. We can extract concepts, identify key terms. Again, very useful usage is if you have some terms which might have some other, maybe some synonyms, some other things. Again, large language models by their very nature are quite good with this type of task. And also for those who are dealing with non-English, again, I'm speaking in English. 3-4 years ago, LMs, they were trained on mostly English text. Now, depending on the model, also smaller languages like Latvian also have quite good support even in these modern models. Doesn't have to even be the best models, even some decent models. So yes, we'll see that actually you can work with other languages. So translation, again, if you're studying for a translation job, right, again, it's going to be a very shrinking field because you'll have to be very, very expert with this. But for general translation, language modernization, these models, sufficiently trained models, are quite adequate, if not more so, right? So, OCR correction, right? Yes, we will probably not get to the actual part where we actually feed in the images, but there is a notebook for that at the end of this workshop. You can actually use it as an OCR engine. Well, it used to be that the LLM sort of cheated. It made a program to run a OCR task, then it transformed this text. But these days, modern state-of-the-art models, they actually do the OCR themselves. It's inside, right? So metadata generation again, right? Again, so title, keyword, short description, collection of tags, all tasks you can do very well with LLMs. And of course, question answering. And also, yes, even nowadays, that's become more and more popular. You can do it, right? To verify your own output, somebody else's output, even of other LLMs. Of course, you might say, okay, if the LLM says this is, supports, says, checks that this is true or false, and is it lying, right? I mean, there's no concept, LLM has no concept of lying, it's just giving you tokens, right? So, of course, obviously, the buck or so the dollar has to stop somewhere, right? And of course, it should stop at you, of course, right? So we'll talk about also what to do when you're dealing with tens of thousands of LLM queries. That's where we are going to. How to verify that, right? What's the point of LLM and batch processing if you have to verify every single query? We'll see that statistically, there are some tools we can use to actually answer these questions and actually make statistically meaningful observations about the validity of these LLM responses. Okay, so yeah, how do we use it? At National Library, at ANDA, some other, right? Some of my colleagues, what we have used is normalizing OCR text, filtering candidates. So, for example, music text, corpora, identifying some transportation terminology in Latvian novels again, and just many other things as well, right? So, but in every case, when you're starting your task, you have some digital humanities task. Your first step, if you're going to involve LLMs at all, is to experiment, right? So, we start what we call this modern prompt engineering, right? Fancy word, right? But you're basically experimenting with prompt, expecting output, right? You're testing because at this stage you expect, well, there will be errors, right? Possibly, maybe you're not getting what you want, right? So, and of course, then the end goal is to move towards to processing the whole corpus. But that part is relatively easy as long as you set. If you can work with one document, you can work with many. So that's a key takeaway from this lecture, I would say. No, so how now you might be saying, okay, I don't really want to learn Python. I don't really want to do notebooks. But I do use LLMs. I know how to write the prompts. I would just like to throw some bunch of documents into some interface. Well, what can you do today? Well, there are some commercial solutions. Surprisingly, none offered by the main LLM providers. Well, why? Probably because, well, usually you pay a monthly fee, right? And if somebody's going to put 10,000 documents in a monthly fee for 20 euros, right? They might actually, you might be actually getting, I don't know, $5,000 worth of services from them, right? So generally it is pay per use, right? That's a general trend and it's going to stay that way, right? So still there are some services. For example, actually we at the library, I've built a service, but this unfortunately can't show to you here because we are not on that network. It's internal use only. Some of you have actually maybe used it, who are at the library, which lets you do this. You submit, say, a zip file with documents, you write a prompt, and that's it. You just need a key, and you don't need to know anything about coding, right? So, one of the takeaways from this lecture is if you see what's possible, but you don't have to write the code yourself, right? There are many examples, and again, you can work with somebody else, right? With some other skills, right? We have to collaborate today. We cannot be experts in everything. That's for sure. So there are ways of setting up. Right now, there is no universal way of just doing mass processing, right? It's all custom made. Now, there is an option which we actually sometimes recommend when researchers come to us at the library. They want to do some research, use large language models, but it's called Notebook. It used to be called Notebook LM from Gemini, from Google. So it is not quite the same thing, It's more so-called RAG, actually, more towards that. You can put some documents you're researching. If you have like 30, 40 documents, and then you can ask questions about those documents. Who has used notebooks? Some of you, right? Good, right? It's quite nice. It's slightly different. I mean, you can use it, and still it could be a supplemental to this, right, to your research. But again, if you go over a couple hundred documents, it's gonna stop being as useful. I think the limit was like if you pay, it was like 200 maybe. I think 50 was a free tier was 50, right? Yeah. So if you have like 40 documents, it might be a good starting point actually, right? So what we are using, basically, we are using this one here. We are using API, right, to actually do this. So Gemini is for source grounded reading, questioning, right? So it's a valuable tool, but not quite the same, right? Again, I expect next year there will be some other solutions, I'm sure, right? But so the idea is we have a document, we have a prompt, and some model will answer, and we are going to check what's happening there. That's our core idea today, at least first session. And then we have many documents. We have some Python code function, and we will have will have a response on sample validation. This already is how you do the actual statistical validation. If you have 10,000 documents, you don't have to check all 10,000. If you check 50, couple hundred documents by hand, you can make statistical inference on statistical claims that on the quality of the responses. You don't have to check by hand all 10,000 documents, right? So that's one of the takeaways again. So, and then you can do analysis on it, right? So batch processing is we are going to do the same prompt across many files. So that's the core idea. One document conversation into something we can do many, many times. Now, so far, we have not run any code, by the way, right? We are just reading, right? So are you with me so far? What I'm talking about on the same page, roughly, maybe some questions, right? So we are going to be using Notebook to send some text on a task to some remote language model and get a response back. We'll check it and see, maybe save the information, see what happened, right? So the LLM is not going to be running inside our notebook, right? It's going to be running on some provider. Again, it could be your own provider, local models possible, could be, but it could be organizational provider or could be some external like today, right? So Google Colab will run the program and it will access some LLM provider, right? So this is a picture, right? Basically here, right? We have our text, right? We have some task constraints. We are going to make a request, so-called post request in terms of web development, right? Which is a standard way. So essentially, we are actually going to be doing something very similar to what ChatGPT does, what Claude does. Pretty much all of these nice fancy interfaces do. They do the same thing actually, essentially. Except they add some extra hidden instructions. Here we are going to be controlling what we do. Basically, all the system prompts is going to be under our control, right? So, and we get so-called JSON response, right? And we'll get some text, tokens, text, right? And well, we'll have to decide what to do. We can validate it again as far as the humanities flow, right? Whether this is meaningful, useful, right? So that's basically what we are going to be doing. All right. So let's see. The workflow also I supply ordinary language steps, right? We choose the source. We have some documents, right? Could be just some text already, right? We describe a task. Let's see, we want to identify some, some named entities and places on people, right? Then we're going to run some code. And this code will send the request to some provider through this API, so application programming interface. It's a general way how different computing systems communicate, right? It doesn't. There are thousands or even, I don't know, probably possibly millions of different APIs, right? But we are going to be using a very standard way of how basically all LLMs communicate with their black box provider actual service, right? So we'll be using OpenRouter. We'll talk more about that. So we'll be getting so-called JSON response. We'll talk about that as well. And then, of course, as far as humanities, we will check the claims, whether it's meaningful, and hopefully save the record, right? For as far as researchers, for replicability, right? So we can repeat this and see what's happening actually. So you we choose a question, right? What we do, the rules, right? We are in control here, right? Notebook and Python. This notebook actually is going to do the work, send the instructions. Open router is going to be so-called aggregator. It's going to route to the actual provider. It's sort of like a middleman, basically. An LLM is actually going to be the actual who is going to generate the response, right? Yeah. So again, I'm not going to go through all of the abbreviations on all of that. You might, again, at your leisure, either now or later after the course, see all of the terms, because some of it might be new, some might not be. Again, you can raise your hand if something is not quite. We are moving at good pace, but we have plenty of time still. So there are Python-specific terms as far as programming goes. There are these notebook-specific terms, right? And then there are LLM terms, right? So there's many terms, actually. They all come together, right? So you don't have to know them all, but of course, you should know what LLM is, right? API, of course, is the general interface, how we communicate, right? So artificial intelligence, right? I think I had a so API key, application programming interface, right? A documented way. Can you see this actually? Yeah, I think you can see it. So for one program to send structured request to another programmer service, right? So again, otherwise the whole world would be a mess, right? So these are hopefully documented ways of interfacing with some other service. And that's how actually the whole internet works, right? It's all basically APIs, right? No, it doesn't have to be internet. It could be other service too in the internet, in the intranet, local networks as well, right? So it's a very generic way of, communicating between different technologies, basically. Now, so we're getting closer to actually running our code soon, hopefully, right? Some data search, I think I even had a digital humanities, right? So JSON, right? This will be quite important. JavaScript object notation, right? So this is a standardized way usually responses are given, right? So of course, metadata we know, OCR we know, right? And hallucinations, right? So again, you probably heard of hallucinations, right? So again, the issue is the hallucinations are getting, I would say, less frequent as far as humans we understand. Of course, the model itself, at its core, there is no such idea as hallucination. It's just the next token, right? It does not, there's no such meaning it's wrong or right answer. It's just next token, right? And we by now know what token is, of course, right? It's, not quite the word, it's the smallest unit, right? It could be a letter, could be half a word, could be a full word, depending on the language, depending on how difficult the word is, what the tokenization is done, right? But, so those terms, right? So, hallucinations. Thing is, like these sort of like the original, the hallucinations we kind of laughed about, the silly ones, right? The modern big models, they don't make those kind of hallucinations, not as much. They still occur, and if you're dealing with thousands of requests, you will get, inevitably, statistically speaking, you will get some bad responses, right? As far as hallucinations, or maybe just malformed responses. That's possible as well, right? So you'll have to deal with that. Now, so time. Now, so yes. So again, I keep talking about how LLM works, right? So again, a repeat of that we have some text, right? I'm sure you've seen something like this. If you read about LLMs, right? They are at their core nature just next token generating machines, basically, right? And it's amazing how this emergent complexity arises, right? So out of that, with all kinds of modern harnesses, agentic workflows, right? But we're getting some really amazing results these days. I mean, we are proving some unsolved mathematical theorems the last few weeks, but at the core, what's happening underneath, it is just these next token responses, right? And in this case, the tram had the highest response, right? So tram could be carriage, a train probably less likely, right? And it keeps going and keeps going and keeps going. And of course, getting the previous tokens in context. So context is king, of course, right? So, and we will be providing this context, right? So you have to remember also that these LLMs, right, they don't have memory. There's no memory itself. Memory comes from something else. The context, right, we provide outside of the actual large language model, right? So, so we provide some token. We're providing some context. It will generate tokens out of there, right? There's some papers. We don't have to read them now. So models, right? Again, every year, well, actually every week, new and new models come on the scene. The major so-called state-of-the-art or SOTA, right, providers, they're all fighting. There's OpenAI, there's Anthropic, there's Google, who is sort of a little bit lagging now on state-of-the-art, right? Meta is even less, Mistral even less, so I like Mistral. And there, of course, are the Chinese models, Kimi, GLM, like some DeepSeek, some really nice models actually coming out of China these days, actually, right? So you have a wide variety of models. How do you choose one? Well, we'll talk about this, how to, there's no one size fits all. Yes, you can use the most expensive model for everything, right? It's just not going to be very financially responsible, and also ecologically possibly not responsible as well, right? You don't really want to be so-called token maxing, right? It's not a good practice, right? You probably heard of this, right? Some companies, for example, Meta, I read about they have a €300 per day budget for all developers. And so they're almost forced to use it, right? So that's you can do quite a bit with €300 a day, right? So it's like their second salary for them, basically, right? And they're pushing really hard. But that's, of course, I think is overkill, right? So hopefully this is sort of maybe a little bit of mania. We are usually in Humanities, we have much tighter budgets, I think, right? So you want to be careful with how much money you spend, and also, again, of course, environmentally also be more sound to use the use a model that fits the use case, basically, right? So yeah, again, these are, I just updated the model catalog. Last year was like we're on GPT 4.5, I believe. Now it's 5.6. I have this new naming, right? And some things have changed, of course. One thing has changed, which might be important, is that pretty much all of the major models now support large token context, meaning up to 1 million tokens. So I forget how much was War and Peace, but I think you can put in War and Peace in one query, technically, right? So, no, maybe half. Well, yeah, but you can put actually pretty large document in a single query if you need to, right? So, and you can actually get a response, reasonable response. There are some issues, even still, these 1 million token contexts are slightly misleading in the terms that many researchers report that if you have at some moment, if you submit a too large a query, even though technically feasible, you have much higher chance of hallucinations, and sort of the model starts becoming lazy, especially about the middle section. Yes, you might have experimented with this, right? So if you put a large, you just stick something large in it, and it will seem like, okay, it's good on introduction, good on a conclusion, but what's happening in the middle, if you're asking these queries, it's not. It seems to sort of there is something happening, some laziness inherent, right? So I expect, of course, as token lengths get larger, some of these issues will go away. Depends on the model, actually, right? But yes, technically, most models now take up to 1 million, right? So yes, of course, there's some other things we can talk about, the open weights and open source, right? So if for purpose of today's workshop, it's maybe not so important, but in general, it's an important concept of open weights, meaning this is the company organization which makes these models. They provide the weights. So this means technically, if your organization can actually run the model themselves. This might be very important for data sovereignty reasons, for data protection reasons. If you have some data you don't want to send absolutely outside, right? You don't even want to risk training on outside for outside sources, so you can run the model locally, assuming you have the hardware and the budget for it. Now, but yeah, very few companies and organizations report open source models, but meaning they don't show how the how the food was done. Actually, they just give you the food, basically, right? They don't show you how it was done exactly. That would be the true open source, but open weights is there. So yeah, so I already mentioned that why we use LLMs at National Library, OCR normalization, music different corpora, right? And there is also, we did a study of one of the papers here by my colleagues, Anne Baklane, Eva Eglaja, and Kristone, and myself, right, on urban transportation in Latvian novels. So here's a little example, right? And this was, we had a so-called old, this is old Latvian, I believe, yes, meaning the old writing style, right? On, yes, we had those who can read it. It's also very bad OCR, by the way, right? So the model, this is an old model, Gemini 2.5 Flash, again from a year and a half ago, right? It could do quite a bit of a good inference, right? Again, you don't have to speak Latvian, but you can see how using this old writing from 120 years ago, it was transformed into very, very plausible sounding version modern writing. Now, so obviously there is always a room for interpretation in this type of a task, because again, sometimes you don't really have the actual source at all. I mean, there is, so the model, it's not even a question of hallucinations. Like this is just nonsense, right? There's some bad OCR, right? The OCR was done 16, 17 years ago and used a very bad model in those days. And so the model has to it has to come up with a plausible, most likely next token. That's all it is, right? But it came out quite well, actually, right? And again, this is a cheap model. This is a cheap model, by the way, right? Again, you might be asking now, would a better state-of-the-art model come with better text? Well, it would come up probably with better modern Latvian writing, but obviously you heard of the old saying, garbage in, garbage out, right? So, I mean, it cannot, the model, no matter how good it is, it has to work with the input tokens, right? And if your input tokens are bad, right, there might not be a full answer at all. I mean, there might be just, it might even the original OCR text, there might be some areas which are not fully recoverable. All we can do is probabilistic inference. We can say, okay, most likely, yes, it was duomes, right, or work or some word, right? Just like it's always been the case, right? When you're working with historical documents, right? You may have some, missing page, half a page of, some old scroll, right? And well, all you can do is make an inference. LLMs can do a great job at this, right? And make very plausible sounding text, right? But yeah, so okay, so again, we are moving towards writing some code, or actually running some code. So the big picture, right? So using chat is nice if you have your subscription to some LLM service, right? Or even a free version. Actually, the free versions are quite good as well these days, right? You have interaction, right? You can copy, right? They're pretty casual, right? But they're good for exploration, right? But if you want to actually make an auditable workflow, right, this API-based approach is, replicable, right? This is what you want to do, right? So again, of course, you have to keep in mind that sometimes, again, if you're dealing with cloud services, I mean, we go back to, I think it was David Hume, right? I mean, there's no, problem of induction, right? There's no, guarantee that tomorrow this notebook will work, right? Technically speaking, right? Just like sun, it might not work and rise tomorrow, right? So same thing goes for providers, right? The infrastructure might change. Next year, there will be some other providers. I can guarantee you that. I think pretty reasonably, right? Things will change. I can guarantee that. But we still have to keep, living on, and we can make some reasonable guesses, basically, right? Of course, again, it's 99% sure things will keep working, right? But of course, some things will change. So how are we doing so far? What I'm talking about? Can you follow me so far, right? So now we move to Open Router, right? So this is a so-called aggregator. Maybe I will show you what it looks like. We can do quick start, right? So it is an aggregator, meaning does not do the work itself. Actually, they do have some local models, their own models, but they are the biggest, I think, if not the biggest, of aggregators or gateway. Meaning, idea is it's like a one-stop shopping, basically, right? You don't have to have subscriptions to all of the providers. That's a big selling point, basically. I'll show you what it looks like. I think here, model page. Yeah, let's go to model page. Yeah, you see here, you can click. I'll open a new window. Yeah, it's going to warn you. Yeah, okay. This is actually going to flashlight. But let me go to actually, this is the model we're going to be using today, flashlight, right? So we are at the open router page, right? That's a link I clicked here, right? I clicked the model page here, right? You go here, like flashlight. This is the model we're going to be using. You can see, okay, 30 cents for 1 million incoming. Outcoming out is usually different price. So you see exactly what it costs. And you also see, interesting here, you can see 2 providers. Yes, they're actually 2 Google providers, Google AI Studio and Google Vertex. That's actually where the money goes. So Open Router, let's go to main page actually. Let's go to main page of Open Router, right? So I think it tells you exactly what we're going to be doing, right? So it's unified interface for LLMs, right? So again, 2,200 trillion tokens every month, right? So 70 different providers and 400 models. So let's go to models page, right? And you can see that all of they are sorted by newest, right? There's GPT transcribed right now, just came out August 6th today. Okay, great. I'll have to check it out, right? So MetaMuse Spark, right? There's many different models, right? And you can compare them, right? So you can compare them. You can see there's text, image, embeddings, audio, video, now rewrite, speech, transcription, different models for different tasks. And you can filter. So again, for you today, I don't expect you to have your own OpenRouter account, because what is the downside of OpenRouter, of course, is you pay about 3 or 4% overhead for this service. Meaning it is always going to be slightly cheaper to go directly to specific provider, right? So if you actually get serious, you have 10,000 documents to process, this might not be the cheapest option. You might actually want to find the model which works best for you and then go directly to the provider, right? We are paying for convenience here. And those providers offer special service for mass processing too, right? But the principle and the code will largely remain the same, because the APIs actually, even though there are all kinds of different providers from across the world, they all use very similar, right? Using similar interfaces, usually often identical. So that's a big advantage here, right? So we don't have to change much in our workflow. We just have to change one line. Say, okay, I don't want to use Gemini today. I'm going to use, I don't know, I'm going to use Mistral. I'll support Europe, right? And so I'll use Mistral. So, but it's a valid thing. So yeah, so you don't have to sign up, right? But it is quite nice. So for you, right? So what I've given you is an API key. You can generate API keys for individual tasks or with individual budgets. So these keys which you all got are good for basically $1 of any models you want, basically, through this API, right? So you can choose what models let's say you want context length, right? It goes up to 1 million. Nobody's doing 2 million, right? So you can use different filters, prompt pricing if you want free. By the way, you can do this, by the way, right? Free. Yes, there are lots of free models, actually. 16 free models. Usually these are testing models, right? If you have really low budget, I understand students, we're always, hurting for budget. You can do some free models. Sometimes small and big companies are doing some testing. These models tend to change, right? Here's the NVIDIA. That's a really tiny model, right? But it is free, right? Alibaba, right? On Cohere, right? NVIDIA again, right? So, well, you can choose your budget. So that's completely free, right? But usually, of course, you can do something, maybe slightly, some money, maybe, right? So, and also the series, categories, right? What you want to do, right? Age. There's a lot of filters, but okay. But let's not go into that right now. But hopefully you get the idea what we're going to be doing, right? So we're going to be using the model. Now, yes. So again, the core idea again with these API keys, right? They are like password, right? And again, have some cases, like I said, if you have an open-ended API with bigger providers, you have to be very careful. You might have an API meaning no limit, right? And then, well, if it gets lost or you send it to somebody through WhatsApp or something or some non-secure channel, the man in the middle takes over and reads your API key, or even worse, what is the issue with notebooks? If you are publishing notebooks, well, it's quite often if you leave in your key, that's a classical error, right? Leaving some sort of API key in your notebook output, right? So again, if you are going to be ever publishing or some resource, right, you don't want to do that, right? There are many bots going through public internet looking for these, and so your money is going to be gone in a second, right? So that's why, like I said, practically speaking, OpenRouter is great for that. You just set the budget, and you can sleep safely at night. You don't have to worry about your open credit, so to say, with some provider. But even so, things have changed. Like things are changing. Even bigger providers, Amazon does not. I don't think so, not yet. But OpenAI and I think even Claude lets you set a budget for specific keys. I used to completely be against using these providers directly because you really had no. I mean, it's so easy to lose your keys somewhere that. I didn't like this open-ended, unlimited budget approach. You just supply your credit card and then you can't sleep at night. But now, right, some providers also offer this option. But with OpenRouter, you can't go over the limit, right? If whatever money you supplied, right, that's the worst-case scenario. That money is going to be gone, but that's it. So with these keys, you can feel pretty secure. Still. Why am I talking about this? Because there are some best practices. Right? We are going to do our first. We are going to do our first code cell, right? We finally come to code, and I think it's a good start with getting your password. Again, API key is technically it's just like password. It's just a long string, right? We need to get it into our computing environment, in our notebook, right? In our session, right? Everybody gets their own session now. So how it's going to happen? So for those who are first time using notebook, right, I'm going to run this cell, right? So what's going to happen, right? So there's going to be warning. This notebook was not authored by Google, right? Because it comes from GitHub, right? It might request access to your data. So technically, if now you're entering API key, this notebook could send an email to me with your API key, right? Technically, right? But of course, it'd be useless because they only have all your keys, right? So, but technically, yes. If you are working with some public notebooks, which are you have not have full understanding, you have to be very careful what you supply. So that's a good warning from Google, right? But we're going to run anyways, right? Because you trust me here. So now what's going to happen? The first cell is going to take a while. Why? Because Google is optimizing things. Now let's see what happened here, right? So it created special so-called virtual machine somewhere on a Google server, which actually lets you run the code. Until this moment, you were only doing a passive reading, meaning that's much cheaper to just read a passive page which has no computation. It's much easier for pretty much anyone to offer this, right? But right now, what has happened? This is a crucial point. You have a notebook running so-called instance, right? And I'm hovering my mouse over it, right? So it should be pretty much same for everybody, roughly. You have 12 gigabytes of RAM and 100 gigabytes of hard disk space. This is a free tier. Everybody gets up roughly the same machine for the last 10 years, roughly. Of course, the actual machine is much more powerful, but everybody gets the same allocation, a little tiny piece of some machine, basically somewhere on a Google data center, right? So, and it's a free service. Okay, that's nice. So where's the catch? With notebooks, you might be saying, okay, I have this nice machine, I can do computations, right? Well, the catch is that it's only good for about 12 hours, roughly max. And also, if you go away for a coffee break or lunch break, right, the notebook might also, the actual data might disappear after like an hour or half an hour, depending on the load. right? Last few years, it's usually around this time. Google's not so busy because we are European time, right? It can stay alive for about an hour, 2 hours even sometimes, right? So we'll see this when you go to lunch, right? If this notebook keeps running. But so the idea is that we have a machine, we have a connection to some computer, virtual computer, right? So called the VPS, basically virtual private service. And now we have a cell running. Look at this spinning. Why is it spinning, you might be asking? Well, because actually this cell has not finished computing. Why? Because look at this here, right? This is going to be the only, I believe, only interactive cell in this notebook, and it's the first one, right? So what are you supposed to do here, right? So I could type something, look at this here, right? And that's hidden, right? So that's it's just a good practice, right? So what you should be doing here, you should be pasting in your long string of this thing here, the SK whatever, right, which everybody has now, should be pasting it here, right? So maybe Harald's and assistants might see if anybody has any trouble pasting. I'm sure you will all succeed with this. You raise your hand and we'll do this. Right. Okay. And while you are doing, I'll show you the questions now. How do I get my keys? I'll show you a little trick, by the way. Those who are, yeah. Oh, yeah. Yeah. So by the way, yeah, again, if you want this notebook afterwards, copy to Drive, you want to see if there's any changes, right? I recommend doing that, right? Again, it's not for data, it's for the actual changes you do. But I want to show you those who have some experience with Google Colab, maybe new. There is an interesting option here, right? So how I will be pasting there's something called secrets, right? Look, yes.
So this is for people who have never used Google Colab before. So you need to press on this copy to Drive, okay? Before that, you were just following Valdis thing.
Yes.
So you need to copy to Drive. That means you need to have a Google Drive. Hopefully you have it. Then in your Google Drive, sometimes it happens that when you run the Colab thing for the first time, it actually asks you to install Google Colab extension. Okay, so if anybody is in that stage, please raise your hand. I'll try to help you, and then you should be okay doing exactly what Valdis is saying.
So yeah, see if you have any problems, this is a good place to stop. So while you or my cool helpers are helping, I will show some extra thing that this is not part of the technical presentation. I didn't put any materials, but this is kind of cool. So we are sort of using Google infrastructure, and this nice little picture is, of course, me, right? So it's my account here, right? So Google provides a way to store your secret information. So it's just like email. So you can store whatever you want, basically add a new secret, right? You can add as many API keys for any services here. It's very convenient. So basically, these are names you come up with yourself. Like I have RTU, I have some different keys, right? So I have this one here. It's called Open Router API Key. Funny name, right? Useful name, right? So I don't have to show. I mean, I can show you that I could show it to you, right? My secret key, but I don't have. I can just copy paste. You see, copy value, right? So, and I am going to put it here, right? Here, right? Control V, right? And that's it. And let's see what happens. Yeah. So this is what you want to do, right? So this is your goal, right? So paste your open key. We pasted it, right? Success, right? So again, for those who have used Python, I mean, we could print it out, right? But there's no point of it. You don't want to show it publicly, right? So what happened is it's saved in this variable, Open Router API Key. It's just a name, but it's of course semantically meaningful, right? Because that's what we're storing. It could be just A or B or X, but this is a much better name, I think. So we have our date. It's basically a string, right? And it is now live in this notebook, right? So we can use it. So now we're going to do our hello world of smallest call, right? So everybody got this far, right? And now we're going to test if it works. Now this is going to be the big test, because if I put in some silly name, something else there, I mean, there will be no error, right? There will be no error, right? It's now when the rubber meets the road, so to say, basically, right? So now we're going to actually test it, see if it works, because we are going to work and make the call. And really, this is basically so-called, I mentioned, this post request using web development technology. And this is what basically every service, every web page which use different APIs, use it, basically, right? We make a call to some service, right? And so I'll show, so we'll go briefly with this. Now, so before we proceed, is everybody here, right? Success. Did everybody get success, right? Yes. Super. All right. So we have success, and this is just a generic call. And what I'll do is I'll shoot first and ask questions later, meaning I'll run this cell, and then we will see what happened, basically, right? And we'll inspect the result, right? So let me see if it works. I'm going to do it. I like living dangerously. I didn't test this particular cell. I tested similar cell yesterday, but I will troubleshoot it. Maybe I made a mistake. All right. Yes. Oh, how funny. This is hilarious. We got some hilarious results. I always knew this would be. I wonder what you will get. I'm curious. This again, this Hello World shows limitations of these free model of these low-cost models. Yes. So I love it. So this is a good hallucination. So hopefully, I want to see what everybody else get. Right. So I got the Chronicle of Baltic, Slovak, and Czech Diaspora, BSSDH 2026. That's what it is. Right. So I'm curious what you guys got. Same? Okay. For some reason, it likes to think Slovak and Czech or something. I don't know. How about others? I'm curious. Yeah. Fantastic. What did you get? Okay. Right. So of course the question might be, why is it so? Well, there are a couple reasons for this. But of course, this means it's a great success. It's a great success as far as technical part. It works. Semantically or useful, as far as it's useful, that's debatable whether it. But the main thing is you should get something like so. If it talks about Slovak and Czech diaspora, yeah. That seems like, yes, we are using the same model. Also, we can see some, now we can also dissect this in more detail. We'll dissect this in more detail. Everybody. So I'm hoping if you have not gotten a response or there's some hang up, ask our helpful assistants. They will help you get a response. Right. So, yeah. So we'll talk about some couple things that happen here. So when everybody is here, right? So, yeah. Now, we'll start now. Like I shot first, and then we will discuss this in more detail. What happened? Right. So. We're all now still on the same page with slightly different results, but we got it working, right? Cool. So now let's discuss what happened actually. So, tool-wise, right? Again, you don't have to remember everything we did, but just general idea. So we used some libraries from Python. These are JSON is built in. Requests comes with Colab. You can import separately, right? So these are needed to make this work, right? These are the two libraries for Python. So what we did is we created, these are actually Python data, but we created some JSON payloads, so-called payloads. That's something we're going to be sending out, right? So what it did is, I think it's all pretty self-explanatory, mostly, right? So we chose a model. You might be saying, so where did this come from, this model, right? How do I know how to write Google Gemini 3.9 flashlight? Well, this is here. You see, Google Gemini. This is here. Google Gemini 3.5 flashlight. That's how this particular model is called, right? So, in terms of open, so messages. So this is a crucial part. This is where you come in, right? So this is what we call so-called user prompt, right? It's just the user prompt. We do not supply the system prompt, right? And our content, right, or context of this query, right? This is what the model had to work with. It's really tiny. What is BSSDH at National Library of Latvia, right? It's an extremely short query, right? And we are using the cheapest Flashlight, right? Flashlight is really low-cost model. It's fast, like Flash, right? But it's also probably the worst model as far as, as far as its size, right? So it does not have very large, how do I call it, training. It was not trained on full data set like Pro versions are. So it does not have actual, it has not, most likely, it has not crawled Latvian library, or at least has very limited knowledge of BSSDH page. Is most likely is not in its crawl space at all, right? Because if you make this query at some of the bigger models, right, you might get the correct answer, right? So it might be interesting. So again, if you have more time, you could play around with. So idea is this: you could, by changing this single line, right, I could get not only different answer, but also different answer for different model. So by changing this, of course, right, you can ask anything you want. You can write, you could copy paste the whole novel in here, of course, as well, right? There are other ways of doing it, but yes, technically here, it's just a big string text, right? It's your prompt, do whatever you want with it. Now, I put some extra limitations on this, right? Max completion tokens, right? This used to be quite important and not so less, but I just didn't want the model to go off the rails forever. Some models tend to do that, right? And they start repeating, basically, right? They start repeating. So you have the control here. You have the option of saying, okay, for this query, no matter what happens, only 250 tokens. That's it. Stop there. Stop right there. That's it, right? So this actually happened in here, right? The Flash model, if you go down here, the model wanted to keep going. I said, stop it, right? This is 250 tokens. So this is 250 tokens. Again, not words, tokens, right? So probably, I don't know, 200 words, maybe 150 words, right? So, right, but it started. Also, it's interesting how it started giving you markdown, right? It gave you 3 hashes, right? I didn't ask for markdown, right? But it's you know, it's structured, right? It's, again, if you didn't know about BSSDH, you would think, okay, might be a good answer, right? But no, the model, right? So, but let's go more about what we got back before the break, right? We have 15 more minutes, right? Let's inspect what else we got. This is actually what the provider, Open Router, sent us back. It sent this huge, response. It gave us some information, what was used, right? What model was used, who provided the answer. In this case, it's Google AI Studio, meaning who actually was doing the work, right? So we start default, and you have choices. There's only one choice, right? Generally, models will give you one answer. Rarely, sometimes will give you more than one answer, right? And also, important point is reasoning, right? This used to be, didn't exist at all, right? Reasoning, so when you're using state-of-the-art models, without even thinking, we are actually almost always using reasoning these days. What does it mean, actually, reasoning? Well, it means is that the model, there was no one prompt. The prompt was used to build another prompt, another prompt, another prompt. We don't really see the full, it's another black box, but what happened is there was a lot of prompting back and forth, right? And the answer was arrived later, right? So generally, for the basic tasks, we don't need reasoning, right? If you want some argumentation, maybe some more difficult tasks, it might be important. But this particular model, by default, we're using the Flashlight, does not have reasoning on, I believe, right? So you have to check this, right? Because if you're using the more expensive models, they might have this reasoning on. So what does this mean is, it means you might be using a lot more tokens as well. Speaking of that, again, you can see how much it cost, right? We gave input was 12, tiny input. Output was 246 tokens, right? Total token 258. And look at the cost, right? This is how much? So that is the 1 cent. That is 1/10 of a cent. So it's less than a 1/10 of a cent. So very inexpensive. If you need 200 documents, if you're doing 10,000 documents, let's calculate it. That's gonna be €1, right? Yeah. So yeah, I think so. I'm doing right. No, wait. Yeah. So you can do 1,000. Yeah. So if it's no, it's tens of a cent. So you could do 1,000 documents for €1, roughly. It's more than 1,000, right? So if you had to classify 1,000 documents, you could fit in as your API key would work with this, right? So again, but of course you need, of course, to be useful, right? So you can see. So right now, this is all what we call meta information, right? You have very fine-grained control of how much it costs, how it was done, right? So, but generally, you only care about the answer. I mean, when you're doing work, you care about what happened here, right? So, how did we get this answer out? So let's go this in more detail, right? So what I did is, this is where the answer came out. This is the actual answer, right? So I have a variable which holds simple response JSON. That's just a name. On it has choices, 0, message, content. So it's a long string, basically, right? So, and again, I think it's maybe useful here to discuss where did it come from? Because let's look at this here, right? So this is our whole response in curly braces, right? And look at this here, choices, right? Key is choices, right? And the first item is this one here, 0. And it has a message, right? Message. And message has content field. So it's it's a 4-level hierarchical structure, 4 levels down, basically. JSON lets us have a structure or data in multiple levels, right? Unlike, say, a table, right? So that's why JSON is used widely, because of course you have this tiered structure. So we drill down to content, right, of the first message, basically. First choice, message, and content, right? So in this particular case. So again, it's beyond the purpose of this workshop to talk of JSON in detail, but JSON is, I highly recommend spending some time learning a little bit more about JSON in general, because it's used for all of the responses, widely used for all kinds of web related technologies. I'm sure when you do your research, you will encounter datasets which are JSON at some point. I'm sure some of you already have encountered, right? So who has worked with JSON data before? Some of you have, right? About 20-30%, yes. So again, so idea is in JSON, maybe I have a link here. Do I have a link? Yes, I have a link here actually. Yes, short introduction. Yes, this has been about 25 years. And the purpose of JSON, JSON.org, right? It's a standard, ECMA 262 standard, 1999, right? 26 standard. And that's actually the reason why it's the most popular data interchange standard in the world, basically. I'm not going to be lying there. So, because it actually has not really, the basic standard has not changed, right? It basically has only 2 structures, major ones, right? And we store either data in sort of sequential order with indexes 0, 1, 2, 3, 4, 5, or by keys. So we have keys and values, right? Objects and arrays. So again, I'm not going to explain more about this too much, but that's the idea. So when we're storing our data or JSON data, there might be named keys, right, or sequential. So in this particular case, our response consisted of key, then numbered index, then 2 more keys, and that's how we got our data out, right? So obviously we did not prove that the answer is historically accurate, right? So now, all right, so the question might be again, how would I change this, how would I use different model, right? Well, all I have to do is change this, right? I am going to live dangerously. right? I'm going to change to something else, something more expensive maybe. Let me see here, models. Not transcribe, again, that would be using the wrong tool, obviously not transcribe. Should I use Chinese? Let's do Mistral. I wonder what Mistral does, right? Let's do Mistral. It's probably also not going to be tell you much, but maybe we'll know. We'll never know. Let's take a look. So, series, right? Series. These are all the providers. Look at all these. All of them are here. Right, let's do Mistral. What's the latest one from Mistral? There's the transcription one. Mistral Medium, 108 billion model. That's medium size. It's relatively expensive, but yeah, let's try this one. Let's try this medium one, right? People are using it. Let's try it. So how do I use it? All I have to do is this. Click it, right? Click it. And what I'll do is I will change this line. Mistral Medium 3.5, right? On, what I'll do is, I don't like, let's see what Mistral thinks of BSSDH, right? And I'll play again. So what will happen, of course, now is if I run this cell again, the old data will be overwritten, right? My response, I'll have a new response. Hopefully, assuming this is the model works, right? So I could also change the content, right? My prompt as well, of course, right? So let's run it again. And will we get Slovak and Czech? I don't think so. We'll get some other hallucination, I imagine. But again, let's try a look. Waiting. Should take a few seconds, maybe. All right. Do we have anything? Oh yes, Baltic Sea States Digital Humanities Network. Sea States. Okay. Like I said, something different, right? So that might be a good challenge to try to find a model which actually, right? Yes, digital Baltic Sea region. Well, yes, Sea States. Yes, but it's actually, seems closer, right? It's actually might not be so bad, right? It's just the shortening is not right, but it's very plausible sounding, right? Right, cross-border collaboration, workshops, conference, and training. I think, well, it's a better answer, I think, right? Again, of course, you have to decide for yourself. And the question, of course, is now, is this completely correct? Where's Iceland, right? Who is missing? And Germany, so now you have to check in, maybe, again, partners. Latvia is here, obviously, right? So it's very plausible sounding, right? Right. And now, of course, we cut off the role of LNB, right? We cut off the role. Where's Anda? Anda would tell us exactly. She sits on the board of, right? So, okay. But yeah, so actually Mistral is much better. But now the question is, how much did it cost? Well, yeah, it was more expensive. It cost us, well, not too bad. It's 1/5 of a cent, right? So we can make, if it's 1/5 of a cent, we could do 500 queries like this. 500 queries for $1, right? Roughly. So, yeah. So much better. So again, this approach, what we did is, right, is, this was, again, as simple as you could keep it while still having it useful, right? There are a couple other things we did, right? So this is how we did it, basically. We posted, it's so-called this post request, and you could do this post request using other tools, by the way, right? There are many other tools how to post it. Doesn't have to be Python, doesn't have to be notebooks, right? But essentially, what happened here? So this is how it worked, because your key was placed here. Python put the key in here, right? And this meant that you are authorized, and an open router judged you worthy, right? And gave you the answer. And that's why it worked. So that's how it works, basically. Yeah. So you pass headers, and you pass your request. And you can also put timeout 60 seconds. I think so it'll try for 60 seconds. If nothing happens, it will skip it, I think. Yeah. So try 60 seconds. Now, is this important? No, this is just extra metadata you're passing. You're saying, okay, we are coming from digital humanities, right? But this is obviously to be made up to something else, right? These are not required to be accurate, but it's nice. It's a good practice, of course. Now, how I usually do this is create a specific function to do this, right? This is sort of like instructions. We have all these similar instructions. Then the next step would be to create a function. Now, what I would like to do is let's try to use a simple, let's see how Gemini does this to create a function to do this, right? Let's see this, right? Because I don't want to go to the next difficult section yet. We have like 6-7 minutes, right? Let's take a look here. Yeah, do the OpenAI SDK, that's a little bit more difficult, but let's see if we can create a new function. This might be a good practice for you guys. So let me write code, right? Let's use LLM to do this because I'm lazy, right? So let's ask, since this is a free version, I think it's Gemini Flash, right? To make a function to do this work for us. What's the idea of function in general, right? In programming and in general, right? We have some work to be done and we want to repeat many times. And I don't want to keep copy-pasting this whole set of instructions of what has to be done. I have my prompt, I have my text, and I have a model. Maybe those two things I want to change, just like in algebra or mathematics, right? I have two things I'm going to pass in as parameters, as arguments, and I want to do some work, right? But I don't particularly want to put all the extra stuff, this boilerplate, right? I don't want to do it over and over again, copy paste. I mean, I could, but I don't want to do that, right? So let's do that. So let's ask. So I'm going to see this. I'm going to live dangerously. Let's try this again. So I made a new code cell. Yeah. So let's make a cell. Empty cell, right? Gemini, right? So it's offering me all these suggestions. Thank you, but I'll ask myself. It's using Flash. It's a very old Flash, by the way. Oh, let's do this one. Flash, it's better, right? Say Flash 3, right? If you are paid subscriber to this service, I think it costs like 10 euros a month. You get the 3.1 Pro, but 3 Flash is going to be good enough, right? So create an empty cell, right? And let's write something. So what do I want to do? Let's write a good prompt. So write a function that takes prompt on model, user prompt, let's call it user prompt on model, and returns text of first response, first choice. First response or first choice? Okay, first response. Okay. I think that's good enough. We'll see. See what happens. Everybody will we'll see how many people will succeed with this. But again, one of the challenges in using LLMs in this regard as a chat interface, right? You have to know what to ask for, basically. If you don't know what to ask for, you will not get the right answer, basically, right? That's one of the challenges. But this looks okay. Let's take a look. Maybe again, there's no harm, no foul if something goes wrong, right? On idea, why? Because this is, remember, very quick model ID, all right? There's a slight hallucination. Response, client chat completions, create model response. Let's take a look. I think it will not work because let's take a look here. Why did it will not work? Because it's sort of skipped, right? So client object, right? So what happened here, right? The Flash looked at our later response. It read through our notebook and read through what we're using later, the client. So it thinks, okay, you already have connection, but I wanted the simple one. I wanted this one here, basically. I wanted this as a function, right? So this Flash model did not make the right inference, actually, right? So this function is not going to work. We can try it, by the way, right? Accept it, right? Yeah, nothing wrong. So this is, notice what the Flash does, right? And many other ones do, right? So you already see why it won't work. First of all, right, that's a function. You don't have to go through a line by line, but it asks for a prompt, right? On model ID, right? So model ID is not defined, right? So what we'll do first here, right? We'll add Gemini, Google, and I'm too lazy, or Mistral. Let's do it Mistral, all right? Let's add Mistral because we are almost ready to. Oh, it's almost. Well, why show me? Oh, it's 1 o'clock. Actually, we're gonna have to finish, and it's gonna stop me here. So this might be actually we'll leave this here, and we'll get it working after the break, right? So this is a little extra thing. So, but going back to our responses, so did everybody get the response back, right? Everybody got that far. Okay, great. So after the break, we will look at some ways of sort of packaging all this together and running over multiple documents. All right, thank you. And I will stop it for now. Okay, well, I'm so used to recording something, but I don't have to record. I'll take off the mic, I guess. Actually, it is a JSON payload to this open router provider. Right, we have our key, which authorizes us, and we set the model, and we got some response back. We saw how the Gemini flashlight, which is a cheap and fast model, didn't give us a very good answer on a particular query. How Mistral actually surprisingly gave, well, much more plausible answer with some certain truths. Again, but again, these models, as far as if you're asking them factual questions, these lower cost models, they obviously are more liable to make mistakes. However, when you use them for some sort of classification tasks and you give them texts, they are still going to perform quite well, actually, right? When they don't have to depend on some sort of external knowledge, right? Because the smaller models might not have as much knowledge as the full-length models. That's just one of the issues. But where we left off, so welcome back, a few more people, right? I was going to show you how to make this idea of this code repeatable, basically. And the way you do it, you make a function, you create a function. And actually, using Gemini Flash, right, eating your own dog food, so to say, right, we're using Flash for answers. We're also using Flash as a sort of a code assistant. Again, not very high quality, but actually good enough. It took me 3 prompts to actually get the code the way I wanted, right? I would have liked this one, right? Write a function that takes user prompt model and returns text of first response, right? And unfortunately, the model, I mean, it did not work correctly. It made the incorrect inference and used some bad assumptions. I mean, some assumptions, they're reasonable assumptions, but it did not know exactly what I wanted, right? So I had to give a more technical specifications. So that's one of the issues. If you don't know, if you add a very general query, you might not get exactly what's runnable. So I said, okay, I want a JSON, I want post, I want open router key, and I got exactly what I wanted. Then, right? And then, third step, we call this refactoring. I said, I want system prompt. So now we come to this part of system prompts and user prompts. So what's the difference? Well, they are both part of the context that goes into a large language model. However, system prompts are for more, well, system instructions, providing the role. For typically, you are a research assistant, you are a classifier, you are named entity recognition analyzer, you are an expert in Latvian language, and so on. Those are like the old, very typical ways in parts of system prompts. You provide the role, context of a role, and maybe also say you only should answer in one-word sentences or short sentences, or maybe answer in a answer specific format like JSON format or XML. You're asking? Excuse me? Yes. Yeah, of course. So one of the approaches you can do, of course, which is actually the hybrid approach. Let's say you have a chat-based, you have a high quality, you have a subscription, you have a good model, let's say ChatGPT Plus, for example, I use that one. You can use it to create prompts, for example, as a separate service for feeding in, of course, yes. So, that's actually, like I said, many of the advances have come from this feeding in the snake, so to say. You feed in them, you generate the prompt, and you feed it in later on again, of course. Yes. So that's definitely part of the process. So yeah, but I'm talking about this here. So the difference between system prompt and user prompt. Well, user prompt usually has slightly lower priority, meaning system prompt is the important stuff, right? Sets the stage, so to say, and the user prompt is actually, well, what you want to analyze, when you get the answer about. So you could do it in one prompt, many of the tasks we do, right? But typically, of course, system prompt has slightly higher preference, and it's actually, well, some models don't have much separation within these two, right? So generally, user prompt is for your inputs, system prompt is for general stage. But as a user of this API, right, you have full control of the system prompt. So what I did is I said, make me a function. Again, this function will be added after the end of this session. It's not going to be live yet unless you make it yourself using Gemini, right? So all the things we did before the end of session, like meaning all this code here, right? It's just the code instruction. What I did is, well, actually, I made Flash do it. Package it into a function. So function is something pre-made instructions, and now the beauty of coding, of programming comes. Now I can run it as many times as I want. 10 times, 5,000 times, 3 million times. Well, assuming I can wait 3 million queries would probably run off my key quite quickly. I'll get no answer after like first 100. Yes, Harald.
Yes, I have a question about your side quest.
Yes.
Where you were making this function with LLM. I had a question also from some participants.
Yes.
I just wanted to maybe give a short comment. So there are many people who are not so familiar with programming, and I would personally not suggest them asking to make functions and then paste them in a notebook, because I think that's a whole
it veers into coding. Of course, ideally you will have somebody already pre-made this function already, right? So you only have this function running. You don't if you are a researcher, you don't really have much coding experience. You don't have to make functions from scratch. But actually, well, the LLMs can make them for you actually these days.
But would it be safe? Because in your case, you said, it will not be working because there was some problem, and there are people who don't even know if it's working or not.
So you have to evaluate your risk profile. Okay, so what's the worst could happen? Let's evaluate, right? So you have API key with €1 limit, right? And worst case I could imagine is it would start to do some long queries. Maybe it would ask, like, I don't know, the cloud anthropic fable question, right? And it cost you $1 for answer, right? For the top model, and well, your key would be used up. That's the worst case scenario I could see. If you have some sensitive information already in there, I mean, it's not the worst would happen. You'll get an error message. So many people, well, again, get quite far. You can get with the error message. You paste the error message. You get the loop. Okay, I mean, it seems like, well, as a programmer, this seems like, not counter, they're not getting at the root of problem, but oftentimes, surprisingly, it works. You can paste the error message, and you say, why doesn't this work? You have to read the error message. You have to provide some human guidance, but you can get surprisingly far by just pasting error messages, right? So again, especially if you so don't be afraid of error message, especially 90% of them, I would say more of them have very simple explanations, which this simple model could do. Because maybe it's quite often, if you're dealing with a live notebook, you maybe just somehow have a lazy finger, you maybe type something like this, right? Press something, you entered something accidentally, right? And of course, it will break the code, right? Nothing bad will happen, it will be an error message, right? So So yes, probably you don't want to do this from scratch, but if you get an error message, you can certainly ask for an explanation. And that's, I think, again, 2 years ago, Google was promising this for a while ago. Last year it was kind of rough. It's getting better. I would imagine by next year it will be even better, right? So there are different workflows. So this assistant is obviously not my favorite, again, because it's not the best model in a free tier, right? But you could, of course, also paste this whole thing and ask what you want to do in some other external tool as well, right? So as long as you know what you want to do, right? So yeah, so what I want to do is, right? So I know what I wanted. That's a challenge, right? So I wanted the function which gets user prompt, system prompt, right? I want model ID and API key. So idea is this: I have prepackaged instructions with two things. Everything potentially controllable, but I want at least user prompt is always going to be something I provide. Everything else is optionally provided, meaning I might not need the system prompt. I might not need to change the model. And I already have API key. I most likely don't need to change API key to something else. So now I can provide this, right? What is capital of Riga? And I have a system prompt answered in one word, right? Well, answer in 3 words. Let's see, I could do that. Let's try this. Let's run this one first, right? It's Riga, obviously, right? So now I'm making a new code cell. One of the things with notebooks is crucial things if you are just starting out with notebooks, that you want them sequentially. So if you have not run this previous cell, the next cell is not likely to work. So if this cell was not run, this function would not exist. So I will call get model response, right? And I'll say, so what do we want to ask? What is capital of Latvia? No, it's something more interesting. So what should I ask? Give me some suggestions. Again, back to this BSD essays. No, something interesting. Any ideas? Maybe Harald can suggest something. Okay, great. I like that one. Okay, so when will humans live on Mars? I like that one. And what I'll do is, I'll do system prompt answer in one word. And then we'll see. Yeah. Answer in one word. Yeah, I like that one. So you are a cosmonautics researcher. I could add some more instructions, but of course there would be no need. Let's see. Never, probably. We'll see. 2030s, okay. Yes. So now what I could do when I'll do this, I'm just curious now. Since I haven't checked how much, it doesn't cost as much. So what I'll do is, right now, since I'm a coder, right, and this is going to transfer to our next session actually pretty soon. What I could do is, let's do it. Let's ask 3 times. Let's ask 5 times. Let's ask 5 times, right? So you see, this is the old way of working with AI, like 4 or 5 years old, right? This so-called autocomplete, meaning I wrote a comment, what I want to do, right? And it wrote so-called loop, right? If you remember your session 0, loops is one of the fundamental things which make basically computing work. So basically, we have something we want to do many, many times, right? So we can repeat, right? So this is how we do it in Python. You want to do something 5 times, right? So on LLM did it for me. So for I in range 5, so 5 times, actually, I'm not going to explain exactly how range works here. So I ask something, and that's it. I'm going to print the response, right? I'm not going to save it anywhere for now. So I'm curious. Oh, no. Sorry. Riga. That's boring, right? I want this one. I wanted this one, this prompt, you see? Yeah. When will humans live on Mars? I like that one. So, you see, that's a good one. Yeah, so we got 5 different responses, all reliable, right? So, yes, answer in one word, future someday. Yes. So, and again, as you imagine, if I press this again, again, I will get 5 new tokens. So what does this mean, of course, that the LLM, this particular Gemini Flash, well, first of all, I have very specific instructions, one word, right? So there is a probability distribution, right, which says, okay, there's many different answers, plausible answers in its inference engine in LLM, right? That says, okay, this token or a couple tokens, maybe 2 tokens or 3 tokens have to be given, basically, right? Many plausible choices, right? So, but it gets back to the idea, right? So you have, if you or LLM made you this type of function, right? Now we get to the core or working loop, right? We write this function, we have a prompt, right? We may only have a system prompt. Maybe we don't need one, but we can provide one, right? Answer in 2 words, maybe, right? Answer in 2 words. Let's do that, right? I wonder what's going to happen. Anything going to change? Oh, I like that one. You see, interesting. Changes, answer, simple system prompt changes it, right? Because, well, if you have to answer in 2 words, the model does not know how to say 2030s, decades away, future decades, you see? So you say 3 words, I don't know, it's going to be very hard, right? Yeah, you see, right? And so on and so on. Of course, again, this is kind of silly limitation, but sometimes this can be useful, right? If you're doing some classification, you don't, so especially for budget reasons, again, we could cut off with tokens. There is a limit. You can say a set specific limit. But this extra system prompt also conditions. We can say, okay, I want to answer as in emoji. Okay, answer in emojis. Okay, let's do that, right? I wonder what's going to happen. Answer in no more, in max, in 1 to 3 emojis, right? I want to see. This is one of this is a classic, but of course, right. So pretty much the same thing, right? So yes, hourglass, Mars and rockets, so some time away, right? Yes, so model has so pretty nice. So again, system prompt generally has slightly higher preference, basically, the way the engine works, the LLMs work, right? So, of course, I could have put them all together in one prompt, just a user prompt as well. Now, so that's the basic idea. Again, this function and these responses I will add later to the workshop as well. Now, to finish this first session, because I want to move on to the second session, right? So there are a couple things I'll touch on some intermediate issues, some intermediate things you can do, right? You can run OpenAI has a separate library. Do you have to use it? No. So what does it mean OpenAI has a library? It means it has a specific tooling for OpenAI, but OpenAI was one of the first, right? So the library is actually used by pretty much all the other providers let you use OpenAI's library for it, because underneath the same type of request is going through. It just adds some extra niceties. I can show you what it has, right? So it has a slightly different syntax, but we don't have to discuss it right now because we want more interesting things, right? You can make some calls, right? So here is system message, same thing. System message or system prompt, same thing. First task or user prompt, right? So this is a source, right? What we're going to analyze, right? System message task, right? So user task. So let's check this out. Same thing like before, just in a different formatting. Nothing else is happening. So you have a text here. What we have a document, basically, a message. You are careful because it may be careless research assistant, right? You get some more interesting things, right? So, or use only supplied source. Do not add outside facts. If the source does not support requested claim, right? Not in source. Okay, I like that. So this is actually one of the good prompt engineering practices. Again, some of the newer models are more strict. You don't necessarily need this, but it's still considered a good practice, right? You need to define what you want out of your results, basically, right? So, again, part of prompt engineering is just basically just your regular writing skills, and so providing good context, right? So that's all really prompt engineering is. Harald has a question now.
So I have a question about this system message, and before I guess it was system prompt. So
Yes.
I'm just wondering, is it something like a variable name?
Yes.
And we include the word system, and then the model will pick up our intention and treat this as a higher priority prompt? Or do we have to be more careful, because there are sometimes variable names? So
Yes.
can you expand on this one? What's happening?
Okay, so what's happening underneath? So these names are just arbitrary names, semantically meaningful, which I chose. You call it something else. They just follow this Python naming convention. But as far as when I'm using it here, right? This is part where I'm making my message, my payload, and what I'm going to send, right? There's no rule. I could switch them around technically. I shouldn't do it as far as, it would just make a big mess. That would be really bad coding practice, right? If I mess them around. So it's like I said, but it's like cooking something, like you could throw the ingredients in the wrong order, right? Nobody's stopping me from that, right? But yes.
But just to be sure, the key names in this JSON are generated by you. It's not that we are following some API practice,
yeah, because
okay?
We are building the API here. Basically, we're building the payload here, right? So on these, I separate variables, so I don't have to type everything here. So the system message. So what's happening here? Again, for those who new are to Python. So content is system message, and notice here, role system, right? So this is, if I want to provide a system prompt, it has to have a role system, basically, right? So that's the boilerplate. This part here, system message, that's my variable. You could say my super cool system message, or my instructions, my system instructions. It could be, you name it, whatever you want, right? Well, you should generally use English for that, but message itself could be in any language, could be in Latvian, could be in Spanish, it doesn't matter. I mean, it matters to your task, but it's allowed. But the actual names of these should be in English. Again, well, should. Again, you don't really want to look at code where somebody use the Latvian variables, with Latvian diacritics. That's not good. So, content, here, content, again, is actually source and task. Well, my user content, I could provide multiple user contents, but here I put them all together. So source is a workshop source and task is first task. So it's actually just one big text. So my workshop source that's a text, it's my document in this case, and my task is what to do. Now, I could have actually put this here inside system message. It's possible. This is just more flexible. So now let's take a look what happens. Also, request preview, right? Model, right? On. This is a preview. Yeah, this is what I'm going to be sending. So this is actually what the model is going to get from me, right? I mean, I could do this by hand. I mean, just type here, right? But I don't want to do that. So let's call it. Let's see it works. And this is using OpenAI. And did I do it correctly? Yeah. Okay. And this gave me a structured, successful model call, right? I just wrote that, basically, that everything worked. There's no errors. And I wrote, learn accessing large language models, right? And it provides evidence. Look at evidence, learn how to access large. So notice how here, even this cheap model, this LLM Flash, which makes stupid mistakes of BSSDH, it can analyze existing document and provide, well, justification on why it chose this. So they will learn about accessing large language models, concept mining. One challenge is OCR errors, right? And prerequisite is only basic familiarity. So there's evidence, right? So in this case, this model responded by showing what it chose, what kind of response, and also provided this, because my instructions were so structured, that they also need to provide the evidence. Again, obviously, evidence could also be fake or hallucinated, right? But in this case, it actually, it's up to you to evaluate is it whether this evidence is actually actual factual, not completely hallucinated, right? Again, the buck stops with you, of course, right? So I'm not gonna, like I said, you could see I'm not gonna go into this more detail because we're going to be running out of time then if you go into each field. But again, the takeaway from these fields is that you can see exactly what the model is giving you back, like the money spent, how many tokens, very detailed information. Like this cost again 0.3, right? Also, it tells you who gave you the answer, which studio. And again, somebody was asking me when I was going to lunch about like data issues, like where do you send the which provider to use, and yes, so this might be important again for data, protection issues. If you want to see, okay, which provider is actually serving your request. In this case, it's Google AI Studio. Again, for some models, you have a huge number of providers actually, right? And maybe you don't want to use all of them, right? So, but again, this is all relatively, I would say, boring detail, but you can see all the data, right? And then, of course, but what I want to tell you before we go on to next session is, right, so you want to save, right? So this is a little bit more advanced, right? So what you can do is you can save so-called hash or a digest, basically, right? That it's not required in this workshop, right? But you can sort of save a little, I won't call this digital signature, but what you did sort of, well, you can sign it and say, you can check then afterwards whether this was exact same response, right? Without actually reading the full response. That's one of the ideas, right? And you can sort of like save it. Now, you could do another task, right? But I think let's move on to the next session, which will continue the same thing we did already. But the main idea is you have this single request, and then you just keep repeating. So what do you need? You need a way of reading documents, multiple documents, right? And just repeat the same task. So let's go back to my little experiment, right, with Mars, right? Let's go back where we're here. Where's my Mars? There we go. Yeah. So, right. So notice here, when will humans live on Mars? Answer 1, 3 emojis. So what could happen if here, instead of always asking the same question, I will always supply a new document? So that's the next step, right? We have 100, maybe we have 1,000 documents. We have a system prompt fixed. Do this, these limitations, this format. Maybe you want CSV, you want, I don't know, text, markdown, JSON. Maybe you have used only emojis, all your instructions, all your limitations, all your context. And then this part here becomes just another document, right? So that's the key idea, right? So in order to do that, you basically need a function to make a single call, and you need some sort of way of accessing these documents. So that's the thing we're going to do next. So process multiple documents. Yeah, question? Yeah.
So maybe I'm getting ahead of this workshop, but for example, if we would like to connect the model with some external website, some external repository through API,
yes,
should we put it as a source, or how would that work?
So the question is, do you want to get data, right? The question is where you want to get data. So here, of course, I mean, you might have an API key for a repository like GitHub, for example, right? That might be a completely different key, right? So you have to load the data yourself first. I mean, right, you need a code cell which loads your data, basically. That would be my general approach. I mean, you probably want to save it. Depends how much data you have. Do you have 10,000 documents, or do you have 1,000 documents? Do you want to store them all here in memory, or do you want to do them one at a time, right? It depends on how many documents you want to work on, basically. If it's 50 or let's say 300 documents, probably enough to load them all. If you have 100,000, you probably need to, in this place, right, you need probably a function or something which calls that data source with possibly another API key for accessing the data, or maybe some sort of link, some way of getting the data there, basically. That would be my recommended approach, right? So hopefully that answers the idea.
Yeah. Like
yeah.
the example would be, for example, there is like Chronicling America that has like digitalized millions and millions of newspapers, and they provide the API, and they want a model to search for it. So should I?
So here you will have a separate function here, Control Z, right? Which you can provide either incremental approach, some need approach that you always get a next answer, basically, the next document, basically, right? And then you make the calls here, and it gives you the textual or possibly even an image if you want an image, right? But some sort of data, right? And that's where it goes into the model here, basically, right? So that's how you build. So you build your workflow from multiple functions, basically, right? So that's.
And do you do it in a collab, or for example, you pay for because you can connect, for example, ChatGPT through API? So
so there are a couple of ways of doing it, right? You could, for example, nowadays you can use things like Cloud Code or Codex, right? Which you can connect directly, right? If you trust and you sort of follow it, you can make the machine do all the work, agentic approach, right? That's possible, but for larger payloads, I would not recommend it. I would still recommend this sort of hand, controlled approach, right? So you could say, okay, you can make Claude build this function for you, but you still need to, control how you get data in, basically. Well, typically, how we do it, of course. Usually, I have my documents in library, shared internal drive, possibly in my local drive, right? I have a machine which can do the work, right? It has documents already. Because again, most of us are dealing with plain text usually. They don't take that much space. Right now, I have 400,000 documents I'm dealing with in one project, and it's only 1 gigabyte. 400,000 documents, 1 gigabyte of data, right? So that leads every document is about 2,000 characters, 2,500 roughly, right? If I'm doing my math correctly, right? So on average, right? So these are newspaper articles, small ones. And so that's 1 gigabyte. And, we all have 1 gigabyte of space, hopefully, on our drives, right? So again, that's just a general approach, because if you have to make an extra call to access some external resource, that is another point of failure potential, right? It's possible at some point the API call doesn't go through the second call, right? And you don't get the right data, or something breaks half through, right? So I like to minimize this type of failure points. You can, of course, run a workaround with this. Like maybe it doesn't work, you try again, So you can add extra. There are lots of things you can do when you're dealing with large corpora to processing, to try again, maybe try a different approach, maybe write some fallback approach, possibly. Or, of course, you can do this. If there's an error, you log it and you write to a file, things didn't work. This is a problem. It's completely possible when you're dealing with, large collection of documents. So, yeah. So to answer, recommended, I would say you have it local, you have it saved already. That would be, do it separately first. That might be my recommendation, if possible. But it's completely possible to also call another API, like you said, and it will work, right? You can try, it should be it should be doable quite if there is such an API and you have authorization to do it, no problem. Okay, so hopefully that answers the yeah. Okay, so all right, so let's go to thank you for the question. Yes, so no more questions for now. Again, so I'm not going to so these some of the materials. Again, we don't have. Again, there's lots of extra reading sources about. There's the Open Router Quick Start. There's the model catalog. There are also some key papers for those who really want to dig in deep. Right, attention is all you need. This is of course a famous paper, but again, probably not what you need today. All right, but it's also yeah. So right now. By now, what we have? We have user prompt, which is going to be our documents, system prompt, that's going to be our instructions, And now we need to basically just a way of doing it over and over, right? So that's what's going to be our second session. So I'll save this one. Actually, yeah, so you can download, right? By the way, if you copy the drive is probably, if you use copy drive, it's auto-saved and you can just close it, right? So what will happen when you close it, when you come back in 3 hours or next day or 3 weeks, you will not have any data, meaning anything you entered as data, meaning API key, right? Variables are all gone. Instructions remain, like all this will remain, but what will not happen, the code will not be running. It will be sort of say dead. I'll show you. It basically look like this. Runtime, disconnect and delete runtime. So this is going to happen. Yes. So it's called state. State means it's all the information, variables, all the information about what you were doing, right? All local variables and files will be lost. Okay, I'm fine. And then you basically end up, you have your text, you have your instructions, but you have to start over basically, run it again and again, depending how often you want to do it. So if you copy to drive, all of this remains with you, right? And you can run it later on at your leisure. So I'll save this already, right? I'll just download this version. You can also download for some if you want, right? There are other ways of saving, and I will stop this notebook for now. I already stopped it. I'm just going to close it. Yes, leave it. Yeah, and let's go to our second notebook. Yes, question? No, I thought I saw a hand. No. Yeah, sure.
So when we interact with an AI through an API, the conversational context is not preserved, right?
Yeah, correctly. And in fact, like I said, actually in all LLMs, it's not preserved. That's the thing. If you're using ChatGPT or Claude, what it's doing, well, actually there is caching, but technically it keeps sending this over, like your conversation, you have this conversation with ChatGPT or something, right? It's being resent. Your history. That's why somebody showed you this, like how much context has been used. They resend it. Yes, they use some tricks called caching to sort of save it, basically. But really, models are the smart ones, state agnostic. They don't know anything. Something goes in, something comes out. Tokens come in, tokens come out. That's it. Right? So the way it works, amazingly that it works, but it works, is that you keep building, you add more and more context, right? You had started, what's capital of Riga? And the next, it gives you Riga, said, okay, I wanted 3 words. That's the next context, right? In a chat interface, right? That's being sent again and again, this longer and longer context. So sometimes long conversations, I know sometimes people have just single chat for everything, right? Not a good practice because you're adding extra, a single chat conversation. You ask about philosophy and humanities, programming, and I don't know about cooking, right? Don't mix all of them together, right? That's why they have projects, right? And individual chats, right? Because technically underneath it's sending all that context again, right? So there's some tricks, of course, how to deal with that. Like sometimes you have a multiple document system, right? There will be some indexing, right? And they'll build this vector database, right? And then you have a RAG, right? RAG, right? And so to get around this problem, right? Because it's like I said, LLM by itself is just a black box. You feed in tokens and you get tokens out, right? And then what has happened in the last few years is that all of this sort of infrastructure around LLMs have not gotten, well, they've gotten better, but the actual interface, the way we interact with them has gotten better. The different loops, basically, what I did, like single loop, right? There are many ways, they're all involved feeding in more and more context in different ways, right? So sometimes we say, okay, we call some external tooling using an LLM, right? Open a web page or maybe write the files. Well, LLM is not doing that. It just has a hook to that, right? And the actual tool is some other program doing that, basically, right? So, okay, but let's go. Again, I could talk about this a lot, but hopefully I answered your question.
So basically, it means it means that if we want to say we want to say the answer in some variable
Yeah.
in other, and
Yes, you
yes,
could do-
yes,
yes, so
and
you-
then we pass it.
Yes,
Yes.
and-
Okay.
Yes, and you could basically then you could build your own sort of your own interface to this, right? Yeah. Nothing's stopping you from that, right? There are already millions of, well, not millions, but many of them already, right? But yes, sometimes your workflow may involve feeding output into, again, another call. But each call is completely independent, right? Each call using API LLM is completely independent. That's a very good question, actually, right? So, no, all right. So let's get to our second session.
Maybe we have some more questions
Yes.
about what happened in the last hour.
Yes.
Before we jump into next one. Okay, I have one kind of workflow related. I
Yes.
see that you keep adding things to the notebook. So I guess that's happening in your notebook. But when people have copied something to the Google
Yeah.
Colab, so it's not showing up.
So yes, obviously, yes. So if I am not saving to GitHub, right, it's not synchronizing. So whatever I do in a live section, right, is not going to show up right now.
So would you suggest that people follow your notebook, or that they should try
Oh no,
copying what you are
I am
doing in their own?
completely no. So what I'm saying, they're completely free to experiment. These notebooks are meant to experiment, right? And save them for yourself, right? And do what you want with them, right? You can add your own cells, notes, and so on. That's one of the tasks I would like, I would like you to accomplish, to learn how to do it, right? So
Good.
maybe-
So still no questions? Okay.
Okay, let's see. Let's proceed. Right. So the next step, like I said, is it's a logical one. If we learn, we can send a prompt. We get this answer, and it's basically so-called stateless answer. Then I'm just going to feed a lot of documents to it. Not many. Actually, we're going to only, I think, feed 6 here, but it could be 600 or 6,000. Right. But I'll do 6. So for this purpose, we'll be using Latvian Economic Review from 1930s. Right. And I chose it actually last year already because it's in English, right? Latvia old, and I believe there's no copyright issue. So it was a state first, publication about some economic, issues. So let's take a look how it will work. So prompt engineering, right? So we'll try to identify we'll do some named entity recognition. Maybe make some concept mining, maybe get some themes, right? So remember, this is a completely new notebook, right? Session 2, right? So what does this mean? That you will have to enter your OpenAI key again, right? So let's do that. So this should be only prompt. So get pass. Again, get pass is going to hide your password, your token, right? Again, you get the same warning. Always Google gives this warning, run anyways. Let's wait. So again, running the first cell is actually 2 steps because it also creates this machine, this virtual machine connected. And now it asks me for key, right? And maybe some of you already saved your secrets, so I'll show you how I do it, right? I have this is my secret I want. I'm going to copy it, right? By the way, for those who already did some coding, there's a way to do it automatically, meaning Google provides a way to read the key here as a code. Right? For those who have done some coding, you can read these secrets because it only makes sense. You are logged in as yourself, so you should have access to your secrets. You can read your secrets directly in your code, right? So, and again, so of course, this means, of course, as far as security, if somebody has your email, they have they have everything about you, right? So it doesn't change security, footprint. So I entered my key. I hope it's the right one. I think it's the same one, right? You enter your keys, and okay, so the main thing is, of course, press enter. Well, hopefully, I think should be okay. So I entered. Well, so what did I hear? API key received in runtime memory. It says pass, right? So, well, this means all it means is it got something. There's no verification it's the correct key. It just means, to answer Harold's question, right? So it's basically, this is a variable, right? It's a variable, meaning it's live data. And it is basically just a text string. And it lives now until this machine runs, right, it will be available. Open a router API key. I could have said my super secret key. That would work too, right? Yes, question, Harold.
Have a safety and workflow
Yes.
related question. So I have done this before, and you can say if it was okay. So I have a Google Colab notebook I'm
Yes.
using myself, and so that I don't have to copy paste API key.
Yes.
I kind of made some setting that it's by default in there.
Yes.
So is it
That's
safe,
bad.
or is it like I'm already kind of
Yeah. Well, no, it's not okay. If it sits on your own computer and you're not giving to anybody, right, or your own Google Drive, right, nobody sees this, right. It's acceptable, but that's not so. But the problem is that is inevitably you will err and you will copy it somewhere where it's public, and then every whole world will see your API key.
Okay, my $1 API key.
Yes.
Okay.
Yes, of course. So, but what I'm saying is this API key expires in August 12. So.
Cool, I'm safe.
So you're safe.
Another question that it was for some people that actually I think it was Google Chrome or something was suggesting to save the API key. Should we be saving or?
So again, if it's your computer, it's a cookie on your browser, Chrome or Firefox or Brave, whatever, Safari, it is acceptable, right?
Acceptable or good?
Acceptable, I wouldn't say it's fine. Again, depends how much you value your key. It's an extra attack surface from.
So it's not totally safe.
It's not totally safe.
Okay.
Why not totally safe? Because what's attack? You go to some public cafe or an airport or somewhere, and of course, but again, and you somehow log in, and somehow some browsers have this synchronization feature, and sometimes. Or even at a university, right? They have these, or this computer, right? You do something, you log in, and you forget to log out. Technically, it stays there, right? So some of the Firefox and Chrome, sometimes they offer some saving.
Okay, I think I'm happy. So you guys here, when you want some comfort, you can save the API key as a default. If you want total safety, paste it in every time.
There's no total safety. There are always. I mean, again, first of all, like I said, if somebody has your Gmail, they have all of your keys and everything, right? So. That's why, of course, you need two-factor authorization. Again, that's an extra step, right? So, but yeah. So again, my answer to this is not to be pragmatic. Set reasonable limits, expiration dates, just good, safe, practices to minimize what we call attack surface, right? So, worst case happens, you make because. What is Harold's talking? Because what I could do, and I've done this before myself a long time ago, right? Bless you. So instead of doing this get pass, I could just paste in the key here, basically, right? But it would stay as a record, basically, in the notebook. And that's why you sort of provide a way of getting this key, but don't actually get the key. It doesn't show up. Because if I'm sharing this with public, right, I don't want any hard-coded keys. It's just a good safe practice, and this is just widespread. It's not my just my own opinion, right? I mean, I'm lazy, just as anyone else, right? So I'm just showing you this good practice again, because inevitably, like I said, you will have some important key which you will you don't want to share it, right? So I shared, and again, right now, all I know it is just a key. It's something. Is it valid? We'll see. Right. So we're going to use the same repository from last year. Again, Latvian Economic zip archive. I'll show you what it looks like. It's a separate repository just for data. It's public data, right? And it's basically, I believe it's a zip file. Yeah, it's a zip file. Latvian Economic Review as a zip, right? So what does the zip mean? Of course, means there's lots of files inside, hopefully, right? I mean, it could be empty, but it actually has some files, right? So, but what we'll do is I'll show you some little extra things you can do, right? I mean, in this case, how you can actually download automatically a zip file, unzip it, right? Because we have to work with it. So this is, in this particular case, right? So I know where this zip file lives, right? You need to know, of course, the address, the web address of this. And in this case, it is this one here, right? Copy link address, right? Right. It's actually here, right? It's this one here, raw, right? Download link, right? You could download yourself. I mean, why do we need this? Basically, we are putting instructions how to get the data, right? Instead of copying it from somewhere, somehow without instructions, then we don't have we lose replicability. Right now, these instructions are actually extremely detailed. For example, they even show you a data integrity hash. This is also sort of like, this says, okay, the data I get, this archive should have this signature. If it doesn't have the signature, it's probably fake data, or it's probably somebody messed with your zip file, right? Because I have this, but I do, because idea being that this data source is maybe not yours. Maybe it's somebody else, but you already did this before. You have a signature. You want to make sure you get the same data again. So how do you do that? You can write signatures. So this is one of the, you can have signature on anything. It could be small corpora, big corpora. You can create a signature on anything. And then you can verify, I actually have exact same data I worked before, right? Why? Because this type of signature, right, it's basically, well, it's not guaranteed unique, but it's extremely likely that it is unique, right? The collision of some other data set generating this type of signature is extremely small, right? So this has some extra, let's take a look if it works. So, yes, so core model, Flash, right? We're going to use a cheap one again, right? Because we want to do extra stuff. So data, Latvian Economic Review, right? And let's take a look how many files we have, right? So what we'll do is this instruction, you can keep running this. These cells are meant to be run, by the way, right? Run them one time, or run actually a couple times if you want. But so what we'll do is the next cell, it checks whether we have any data. And what I say, we have data. Remember, I spoke about Colab, right? It gives you a computer, basically, right? What do we have here? We have 100 gigabytes of space to work as, but it is not permanent. It's a temporary space. After 12 hours, it goes away, right? So, and it lives here, right? It's almost empty. It's a drive, basically, right? So there are a couple ways of doing it, right? You have data sets. Those who are advanced or intermediate, you could attach your Google Drive here as well. So you have access to whatever you have stored. It's kind of neat. I'm not going to talk about it right now too much right now, but let's pretend we all have no data, right? We need some data, right? Because the machine needs data, right? So we need documents. It's a computer, virtual computer, right? And it doesn't have any text, and it doesn't have anything. Well, it's not true. It has California housing. This comes from Google. They always give you these small data sets, actually, right? But we don't need those, not in this notebook. So let's run it. Let's take a look. So I run it, and notice what happened. This cell, I have data. Latvian Economic Review, right? And I have my documents. All plain text documents, and I can even inspect them now. Look at this here, right? Latvia International Trade. That's very typical of what this kind of plain text documents we deal at the library, usually when I prepare them, right? So it has this time I have very tiny metadata, and I have a document, right? So again, let me close this one, and let's close this one, right? So when you run this cell, it will create your documents in your drive. Again, if you don't want to run this cell, you could do it by hand. You could upload this. There's upload option. You could do it one by one, right? Not very efficient, right? So everybody has this data. Check if it works, right? You should all have the same data, right? Yeah, great. Maybe somebody who doesn't have it, maybe this might be a good time to stop, right? Because we have some assistants here to help you if you don't have this data. Because I made this, I'm going to keep talking because, I said I like talk, right? I made this cell that it keeps working if I do it again. Let's try it. So it checks, do I have my data? Corpus already available. Let's double check. Because right now, you see, I downloading, right? But if I run it again, let's take a look. What will happen? If length is expected, you see, corpus already available. So this cell you can run 5 times or 300 times. Nothing's going to change. If I have my documents here, well, 419 documents of something. I mean, that's a verification, basically, right? I don't need to run it again. I already have the data. So that's a good practice, by the way. If you once you get to get comfortable with Python and analysis, to make the cell check whether it needs to be run again, basically, right? It'd be kind of, I mean, on how I did this, I check whether the length, right? If length is exactly what expected, I don't do nothing. I do nothing, right? I said it's available. Otherwise, I try to download the data from GitHub, right? So, and I also check the, I mean, this has some extra steps, some extra security steps, yes.
Yeah, I have a question or maybe clarification. So, as I understand, so the zip file you have somewhere else is because you have a lot of information, you have just compressed it. So in case people want to use this notebook with their materials, they first need to zip their content and put it somewhere and put the exact URL, and then it will work and you will not have to think about details. But basically the zip step is just because the material sometimes is really big.
Well, and also they don't have to put them under Latvian Economic Review. They basically need their own URL where they put it, right? So, for example, you might be saying, okay, but how about I have my like a semi-hidden data? Maybe it's under some paywall or some sort of API or itself, right? Obviously, here you need to the URL need to include the API or maybe again hopefully hidden, right? Don't code the actual full. Like for example, we're using cloud-based, Latvia in LLM Mākonis, right? It provides an option to this, right? So the whole issue is this: that if you're using Colab, if you're running this notebook locally, right, you don't need to do this. You already have the data, hopefully, right, on your machine or on your shared network drive or something like that, right? But in this case, I need some data, and this particular Colab does not have that data, right? By the way, speaking of zip files, this is again practical, technical. I know you guys are learning to research, but technically you want to work with zip files as much as possible. I used to think, okay, I'm working with text. Why do I need zip and zip and zip? But the thing is, zips are much more efficient. If you have thousands of text files, you want to keep them in zip files, actually. Don't unzip them, actually, unnecessary. Here, we don't have too many, right? But in general, you want to stay in a zip file or some other compressed format. Why? Because the way computer drives work, they're accessing these individual text files, even on SSD, right? It's not very efficient. It's much better to actually use a zip file, extract files from zip file as expected. So in this case, I'm sort of, not following the practice I usually follow these days, right? Why? Because I only have 419 files. If I had a couple thousand, I would stay with zip file, meaning in using Python or some other language, in this case Python, I would access it directly from the zip file. Don't unzip it, basically. That's what I'm saying, is if you're dealing with more data. So, I mean, there's lots of cases. I mean, investors can also attest to this, right? Working with larger collections, right? So if you're going through text files, a big folder with many files, it's much slower than having a zip, have the program open the zip, and then you process within the zip file, right? So it's just a technical thing, right? If you have a couple hundred files, not that important, but dealing with larger data, it becomes important. So is everybody has this data, right? Not yet? Okay, Harald will help. So it should be sufficient to run this cell. And yeah, and this I added some extra. You can see how it's done. Some things are completely for example, the SHA 256 is just an extra security step. Usually you don't need to be so precise, right? But if you're dealing with some data which is crucial, where you don't want somebody to change your data on the way over, right? That might be important, right? So if there is such a risk. But in general, you download, right, and you make a directory if you want here. There's some nice recipes, and then you basically extract it, right? You open the zip file and you extract it. It's just like 2 lines of code. Now let's take two documents once Harald's finished, and then that's our next step, right? Yes. So we'll use 2 documents, State Land Bank and Gypsum, right? So let's look at these documents while we are waiting, right? So let's see if we can find them again. Oh, excellent. Actually, we're gonna print them here actually in a moment. Yeah. We could actually, of course, print them by. We could also find them. These 2 documents we're going to be working. We could find them here, right? You can scroll. There's only 400 of them, right? Gypsum one. This is kind of funny one. Not funny because it's kind of leads to some issues. So, and we can see here, right? This one here, right? Yeah, that's the one. Yeah, Gypsum, tile Gypsum. All right. Export of plaster of Paris, right? And also State Land Bank. That's 1937. And again, you can see also, well, I'm going to keep talking while Harald's fixing the way I'm naming files. This actually comes from our library, but we try to keep consistent formatting. So what is LERQ, right? It's basically a shortened the name of the whole Latvian Economic Review, right? And then some extra letters, right? So 4-letter abbreviation. Then you have the year. Then you have what you call them SO1. How do you say it in English? Sejums. Volume. Yes, correct. Volume. And NO8, of course, is the issue, right? 8 issue. And of course, what's 0 to 9? This means it's at page 29. Right. And again, of course, that depends on your documents, right? Some have nice, the file names have nice description, not nice. It's basically metadata, basically, right? It's metadata, right? And it's nice to have it actually when your file name actually has descriptive metadata instead of having just a completely, ABC, some nonsense, right? So, okay, so we're good, Harald? You good? Everybody's good. Okay, so let's keep going. So, what I'll do is next cell is going to print it out. Basically, right, so these are, basically we are going to open these 2 articles and going to print them out. You could do them one by one, but here you could add some more articles here, basically, right? So all it does is it prints them out. What does it mean is it doesn't say training documents, right? Right? It has a name, right? So we have a so-called dictionary. We have a live memory of these documents. Yes, we have our data already saved on this drive, on a Colab drive, not on our Google Drive. And also we have them in memory now, right? We have these 2 documents, right? Again, so this is the first document, State Land Bank. You can read it. Nothing particularly exciting, right? It's basically a celebration of 15 years of agricultural bank, right? Right. Again, on gypsum, right, which shows different extensive layers of gypsum stone, right? So now, so this might be basically the humanities related question. So what do we expect, right, in talking, right? To write here, we could write here, by the way, right? You could write here or write it underneath, right? You could write under here as well, right? Just write something here. What do we expect, right? Do we expect entities, right? Probably banks, right? I don't know. Rural credit, right? Well, state, yeah, I would expect rural credit would be present in State Land Bank, right? Something like that. And what else? Why? Well, the bank, right? It provides credit, right? Gypsum, article about gypsum probably doesn't have articles about credit. Well, again, it's hypothesis. I don't know. Maybe hard articles about gypsum would have some articles about credit, right? So this might be something, just write some notes here, right? So I predict So here, where's he? You could write him here, but if I write here, yeah, yes, I would say yes on. So this I'm editing just a text cell, right? And by the way, these square brackets have no particular meaning. So yes, you can write like this, all right? And you can write here uncertain, right? Again, this is not code. This is just markdown, right? All right, and you can say what do we expect here? Do we expect? Well, we can of course read this article, right? So maybe I should. It's been a while since I don't really particularly want to go in details of this article, but let's see. So we expect cities, right? Expect cities, right? Named entity, city, geopolitical, right? Cities, right? Do we expect names? What else do we have here, right? That's basically it, right? I don't know. And here, do we have? We don't have almost nothing, right? I don't see. Do we have any named entities? Just the bank, right? Banks. Yeah, just banks. Who got Zelzitis, right? That's Mr., right? So on persons. So persons, of course, persons. So you have persons, organizations, right? Right. And what else do we expect to see there? Okay. So you can see here, you can write some predictions. Again, well, mark your own assumptions, what you expect to see. And of course, you can also write why. Right, so I'm not going to do the why. I'll let you do that. Yes, Harald, you want to ask something?
Yeah, I'm following and trying to understand if I follow what you are doing.
Okay.
So let me say it, and you say if it's correct. So you are briefly reading two samples to see what's in there, and then you write it in this prediction table in order that afterwards you can check if model performed good or not. Something like that?
Sort of, yeah. Okay. So sometimes it might be good to start, because we as humans, we have this unfortunate tendency to sort of match our predictions to post factum, basically, right? We get something, and then we sort of provide our own justification afterwards, right? So it might be, as from a research perspective, it might be better to have state some assumptions up front, basically, because it's just the way our psychology works, right? So we pattern match, and so we provide justification afterwards, right? So it's better to make some assumptions first, right? Obviously, usually you don't do it so strictly, but it's a good practice. So now. So next thing is, now we go back to technical stuff. So we configure the open router. And this time again, I'm going back to the OpenAI client, meaning we use the way OpenAI offers. But again, we are not going to be using OpenAI models. I mean, we could, if you want a ChatGPT, I don't want to pay for them. They're expensive, right? Even though they lower the prices, that Luna models are now kind of cheap, actually. We can try with the Luna ones. But OpenAI is just basically sort of standard, has a standard library for accessing it. That's why. So OpenRouter, OpenAI, completely two different things, right? OpenAI is like $1 trillion company. OpenRouter is like $1 billion company. So 1,000 times smaller, right? So, okay. Now, so API records, I forgot what this is. Okay, let's take a look. So build prompt IDs, make request record, right? And let's see if we are gonna call it, right? So we basically, all the cell is, we don't have to go in details. We set up these functions, right? I pre-made them, right? So I'll run it, no errors. So I have my helper functions ready, but I have not asked anything of OpenAI of OpenRouter, of Gemini. And let me see what model I'm using here. Do I have a model here already? Or will I set it up OpenRouter key, right, API? But I'll provide the model later, I think, right? So look at so this is going to be what? System prompt, right? Right? You are a digital humanities research assistant, extracts the named entities from the supplied historical text. Very basic prompt, right? System prompt, right? And task also identify the named entities in the source, right? So record key, right? The bank. Source name, training file names, source text, task. Let's see what we have. Right. Now, So run one. So look at this result. It should be, even with this model, flashlight. Remember, this is a cheap, new, relatively new, but not by far from the best model, right? Remember what it told us about BSSDH, right? But it's now analyzing a text we supplied. So what's happening here? When I run this cell, I have basically provided, I have baseline, the baseline system instructions, right? And I have the task, plus I supply the document, right? So I supply this single task, run one cache. So I'm calling Gemini Flash, right? Took me 3 seconds, less than 3 seconds. And it gives me Hugo Dzelzītis, right? Everybody get Hugo? Yep. And get state land bank. And it also gave me Latvia and Latgale, of course, as well. So even this inexpensive model, at least in this, of course, it's a sample size of 1, right? But it's pretty promising. Obviously, now, once we start running with more, by their very nature, these models will sometimes, well, they don't tend to hallucinate these. By the way, with these type of instructions, they will not hallucinate fake people, right? That's extremely, I would say the newer models don't do that. But what they might do is failure to omit, meaning they omit some, but they might miss if you're going to feed half a book or a full book, right? It's not going to be able to give you all of named entities in a whole, novel or a novella or a bigger article, right? So, but for these type of small, couple thousand character documents, it will provide this. Yes, question of Harald's.
Yes, I have a question about that system prompt, or rather the role prompt. So
Yes.
I've been always puzzled. Why should we give such? Because it seems like such a basic prompt. You are just a research assistant.
Yes.
Be diligent and truthful. So, and on the other hand, if we are digital humanists, the things you are saying are so basic.
Yeah.
So I was wondering, can you comment on this? What would happen if we give this baseline
Yes.
system prompt, and what would happen if we would write 7 sentences kind of pointing to exactly which nurse system we want to employ and something like that? Because
Right. Okay, Harald, so that's why we are here. Let's experiment. It's
let's
fun.
see what happens.
Okay, so this, instead of this humanist research assistant, right? We could just basically do nothing, provide an empty string, or maybe give it different base. Maybe say you are a poet or something like that. No, I don't know. No.
You are a researcher.
Okay.
What will happen?
Yes, this. What I'm saying is, most likely it will work just like that, just exactly like that, very close. Because, by the way, this is a reminder of early people were experimenting, and they found that this role was in early LLMs, meaning when I say early, it means 3 years ago, 4 years ago, right? That's ancient history, right? These were very crucial, because the early LLMs, they really needed this prodding, this context. Newer LLMs, they sort of could pick up on this, right? Meaning they might miss the digital humanities part, but assistant. So you are a researcher, right?
Let's say you are a computational linguist.
Or you are a
And so let's see if it really...
linguist. All right. See what we have now. All right. Now, I'll run it. All right. Let's take, oh, wow, interesting. More interesting. Interesting results. Well, we got the organization, person, lock, right? These are all, by the way, so this model, even though it's cheap, it knows about named entity, these abbreviations, it knows about all the basic stuff, right? Obviously. Now, dates. I think it got more into dates this time. Quantifiers. It provided me all the quantifiers. I think it got much more. Look at this. It gave me all. Well, now, of course, the task would be, if I was doing this seriously, right, I would not trust. Well, what did you get? Something very funny. I want to see if it's not too rude. I would like to see something. Okay, maybe Harald can Harald look at it. Yes. Well, it depends what you supplied. I mean, if you told to write a dirty limerick, it of course would write one for you, right?
No, you don't need to know that.
Okay. Okay. So the question, of course, is for all purposes: was it because of the system prompt, or was it just you run it a couple times? I mean, because remember, what you can do is, if I keep pressing it, it will keep sending new queries, basically, right? Why? Because this one here, run one cached, right? So let me see. Actually, if it says run one cached, I didn't check. I forgot to check this function. Will it do it again, or will it? Let's try it again. So I expect. So remember of this probabilistic nature, right? So you combinational linguist. Let's see how this. You are a newspaper editor, right? A newspaper. For a youth magazine, I don't know. Well, again, I mean, it's like it's second nature to add some more context, right? Again, more context usually better, usually, right? Sometimes too much, but so you see, it thinks computational linguist wants all of those numbers. For a newspaper editor, it gives you just Latvia, who got Zelzits, institutions. And notice also, another interesting side point. For a newspaper editor, it didn't give you these abbreviations, NER ones. It just gave you the actual names, but it thinks, okay, you don't need to know that they actually have these specific NER type, right? So what else? Do we want to do one more for this? So what other role? You are a I don't know. You're a politician. Oh God, okay. You are a politician. Giovanni left. We are talking about this. Well, you can also provide a leaning politician, right? Yeah. I don't want to write this word populist, but okay. So that's gonna. Hey, my fellow citizens, right? So we got this writings of the speech, basically, right? So same information but different wrapping, basically. Well, this sounds actually going with 1930s. This would not be out of place if you those who studied Ulmanism. So yes. Remember, we were under a relatively mild dictatorship at the time, so this would be actually quite appropriate this time, right? But again, you can provide also extra context. So again, you see from these examples, right, that the system prompt, the baseline system prompt, well, it changes the type of output, right? So, of course, as a computational linguist, well, or as a computer scientist, of course, I do provide some of information, but I usually also what I do is I say, well, how I want to see this, right? For example, right? Yeah. So you are a researcher, right? That might be enough, right? Provide, okay. I would do in task here. I would probably, because again, remember, it'll give me also task, right? I'll put here, provide outputs, right? Outputs as a JSON, for example, or or XML if you want, or Markdown as JSON, or valid as valid. So yeah, so some of these things, some of the things have sort of, again, in the last few years, well, we only saw here, it does make a big difference, but some things might not be absolutely crucial, but one single word might make a world of difference in your system prompt. That's valid JSON, right? And again, I did not specify what JSON, right? There are many ways of writing JSON, for example. Let's take a look. Yeah, you see? This is how I would usually want to see it. This is how I usually want it. Because why? Because I can convert this into some sort of data structure, save it afterwards, right? And I have name type, that's something I can work with and analyze and add into some bigger analysis platform. So can everybody on Zoom hear me still? I don't know. My mic still on? Yeah? Okay. So you saw, okay, so we saw this idea. Now we can refine, okay, so this is, yeah, so next step, right? So this is usually as Anna can attest to us, when we usually work on these extended prompts, this is not an instant process, right? And again, it's not exact science, right? There's no one way. You look at basically some results and see if you are getting something that you expect, right? Sometimes a single word might make a big difference, right? So, and again, we worked a lot with the older, weaker models such as Flash 1.5, which is like 2 or 3 years ago. So it's like then the exact prompt is very crucial here, right? So one of the older advices was that negative prompts perform worse, right? Now these days, negative is pretty much okay to add negative, right? So you can do negative, but you have to be careful, of course, as you start writing longer and longer system prompts, that you don't contradict yourself, because obviously the model is also gonna have problems with that, right? And it will sometimes make the decision on one side or another side, right? So you want to be very precise, right? So this is your writing skill, right? Your knowledge of particular language, right? So preserve spelling source. Yeah, that might be crucial because again, models, if you have some spelling errors in the document, it will tend to correct them. But if you are researching, maybe you don't. Well, depends what you want. Again, if you're researching general concepts, maybe you want the errors fixed on a run, right? Maybe you want to do it later, because personally I prefer to do it later. And I see, okay, there's very typical 2 different ways of spelling one person, right? Or maybe it's not the same person. Again, I personally as a researcher want to dig deeper, right? What's happening there? But so generic roles, unnamed groups, dates, currencies, abstract concepts. Again, so, and again, by the way, you could do this whole thing also, this step, right? We could do it also on a regular chat platform as well, right? And then you supply the document. That will work again, but it's not going to be so precise because they do add some extra things, and also you can't really turn off the thinking. It might overthink too much actually for these type of tasks, right? So the API-based approach will be better, right? So let's run, see what happens. Yeah. So this is very similar to what I did as a researcher, right? Person, evidence. Oh, so it also provides evidence, right? Routine in was restore. Yeah. Okay. So these are the key points, key named entities, and I think we can give these all valid entities. I believe money would not be a named entity, right? It was a little too much, right? So we don't count that as So so this is extra helper functions, right? And we can check whether something occurs. So what happened here? I run this cell, right? Now, to completely understand what happened here, you need to know more about Python. And you know what I did is I put it in a so-called pandas data frame, which basically is a tabular format, right? And this is, of course, very typical format when you're doing data analysis. And then because you can save it to Excel, you can save it to CSV, you can save it to database, right? This is already the next step for analysis. We're not going to go deep today in this section, right? But basically, we converted. That's what you usually want to do. You have a document and you want to extract very well structured your data in very well structured. We could have kept it in JSON, but here I extracted in a tabular format. So is it the perfect one? Maybe not, but it has 4 columns, right? Mention, category, evidence, and true, right? So we have a couple more times. We'll keep going with this, by the way. So concept mining, right? So same approach. We have a concept discovery system. Again, system prompt. Identify up to 6 important, right? By supplied source. So again, if you say identify exactly 10 economic concepts, then the model will try too hard, right? It'll probably overthink, basically will try to, well, not hallucinate, but it'll try to make up some things, maybe synonyms and things like that. It's not going to work. So up to 6. It's relatively loose, but lets you have up to 6. So I used to write 1 to 6 at least. Well, but the thing is, maybe there's no concepts in the document at all, right? So do not add concepts based only on outside knowledge, right? So we don't want to take some knowledge, maybe it knows about this happening, about this event from the training data, but the model was built, but we don't want to use that, right? Because again, we want to use it for analysis, right? So let's see now. And again, yeah. So 5 concepts. So this is a concept extraction. Agricultural credit, right? Agrarian reform, land consolidation, debt conversion, and rural infrastructure, right? And again, if you are doing this with literary text, right, you could also use something similar to extract even metaphors, which we used to think it was really hard, right? And but now we can also even extract metaphors and analogies and some more advanced literary concepts as well, and some themes which are not explicitly present here. This is a relatively simple task, which for last few years they've been quite standard thing. But you can also extract things which are not directly explicit in the text, right? You can extract some external themes. So here, since this is dry economic report, probably not much of probably they didn't use any metaphors here. I don't know. So right. So you have, and also you have connection. So this is great, because also, yes, you say, okay, you want to only extract agricultural credit and banking, right? But it's good to have justification for this, right? So this extra step connection, right? So obviously this costs a little more because we're paying for output tokens cost more, right? But you have now a nice way of actually justification, right? And you can it makes your life easier, right? Why does the model provide this concept, right? So hopefully, again, this article was easy enough, right, to see that this actually is, in fact, looks correct, even this cheap model, right? I would like to say, of course, again, if I want to try, so what happens if you're not, so what should you do if you're not getting the right kind of answers, right? Well, you should be asking better questions, right? Meaning write better prompts, system prompts. And of course, you could also, if you think you have a great prompt, well, you could try then here, you can run a different model. Let me see here, right? Model, I think, yeah. Oh, you can find temperature. Let me see here. Does run when cached? I haven't checked the function. It does not have, okay, yeah. Unfortunately, this function does not have the model change, but I could add the model. This does have a tokens and temperature, right? Believe. So you could add maybe be more diverse, meaning add more heat, meaning heat means entropy, means model might make more, sort of say, I wouldn't say hallucinations, but be less predictable, I would say, or also limited tokens. But yeah, we could check different model if you're not getting the right answers, but primarily we start with the prompt. So work on your prompt. So now we can try again. Again, we're not going to get, so I expect you'll get very similar main concepts, but evidence connection will be, of course, written slightly differently. Let's take a look. Yeah. We got all 5. So now, if you run the same question 1,000 times these days, I would say these concepts will appear not 1,000 times, probably 996 times. So most of the time, again. But evidence connection, of course, will be slightly differently formed, the language, because, of course, correct English these days. But so now, if you want the answer in Latvian, or I don't know, we could ask for an answer in Latvian, right? We could say, provide answer in Latvian or in Spanish or another language, and it will get a language also. Most modern models will do that. Yes.
So about concept mining in Latvian, let's say, or a smaller language, and if the data are older language and maybe poetic language, how good would the technology work for that data?
So 2-3 years ago, the situation was that only the best models, expensive models, supported Latvian language at all. Now, these days, Mistral support Latvian language, even last year's model, Gemini, pretty much all models have some Latvian support. It's still not as nice, as flowing as English, right? Because English by far dominates the training data used for large language models. English language dominates. So you have to experiment. Still, it's getting much better, right? We could, I mean, like I said, I don't know, some people are not here, don't speak Latvian, and we could try some, right? We could try in Latvian, and we will get answers, right? So, answer in Latvian. Let's say this. I'll add for now, just add in Latvian. The answer in Latvian. Let's see if this is enough. It's just a single sentence, right? Maybe I should in Spanish or I don't know, some Estonian, which I don't speak, right? So we can try. So let's see if this is enough, right? Because the thing is, we are corpora in English, right? But we can do this here, right? Let's see what happens. I expect it's going to be far from me perfect Latvian. Let's take a look.
I will add another question, and if it doesn't work so well, maybe there is other methods to use instead of this concept mining with LLMs.
Yeah. So yeah, there are other ways of approaching this, of course. Yeah. But actually, of course, here since we had, let's see if the Latvian. Yeah, this is a. Yeah, it's getting the grammar is getting better. Not perfect, but it's getting much better. Even this cheap model. Yeah. Yeah, so what it does is, okay, but it'll, of course, you probably have some experience as well. For smaller language like Latvian, sometimes some words are very strangely translated, or sometimes still, right? So I'm sure you have some experience as well for those who come from using some other languages, right? But yeah, so it seems it's already quite decent. But yeah, so if you want to add some concept mining, right? So if you have a text in Latvian, right? So, well, and again, the old way, of course, you need to have some, if you have the keyword-based, of course, approach, of course, is this classical rule-based approach. If you know your domain, of course, the main thing is, of course, knowing your domain, what you are researching. So you could do that, but you can do there's some other approach beyond the scope of today's lecture, right? So, are we taking a break? Yes, we are. Okay, so we'll keep talking about this, right? So there's some ways around, but basically the better models, they will pick up on the Latvian language. That's the answer. Even this model.
Yeah, I might add about older language rare forms. So the problem seems to be the false positives more than model being able to find the old words. So if we ask about like to find words on specific category, such as our experiment with vehicles, the transportation.
Yes.
So it found like very exotic vehicles, also like erroneous OCR, forms that probably were not in his training data, in their training data, in its training data. But what is inferred from the context that these are vehicles, but the problem was false positives. Half of the results were not existent in the data, and we needed to go back and filter those out. But this is good news that the model found the older forms by like inferring from meaning.
But also, like I said, it'd be interesting, this paper on our transportation, we run this on I hope people can hear me still. We run it on, of course, the Gemini, I believe it's 2.5 or even 2.0. It is older models. And the language support, especially Latvian support, was much worse then, right? So it would be again worse replicability to try it again. See, the amount of false positives would drop, right? That's my hypothesis, of course, but I would say it's most likely true. So again, yes, a question, comment?
Thank you very much. It's a great lecture, but can I add something according to this great question for low resource languages?
Yes.
I mean, this is very trendy now in the world that low resource languages are creating their own models. So probably, I suppose, in Latvia, you do not have your own LLM pre-trained according to Gemini or Gemma or something like this. You didn't do. But that is the way how you can really good... You mean? Because it depends on which data sets are trained and how
Yes.
the processes are prepared and how tokens are prepared. That's why. So architecture is very important to be, let's say, adopt to this syntax and semantic view of construction of the language for the low resource. Yes, that's why I wanted to to tell you that.
So we are actually just talking about this during lunch with Giovanni and Anda. Thank you for your question. So yes. First of all, we don't have a nationwide model for Latvian specific, unfortunately. But yes, it's been proven already for specific domain-specific tasks. You can do something called supplemental training, take an existing model and train it with your data for specific task. It's just that we're using LLMs basically as a chainsaw, or I call it Swiss Army chainsaw for everything, right? If you have a very specific task, it's been proven, actually, there's some nice papers about this, that you can take a relatively cheap open weights model and maybe pay about, I think, $500 in training. And you can get better performance than generic, this type of model. You can get better performance. You have very specific tasks, you can train it again. And this is actually the approach we got. This is a general, of course, machine learning approach in general, right? Yeah. So
we have to go to the break and
we'll continue with this.
We'll continue
this again. You'll have some time to do some individual independent work, but we will continue with it. Now we often explored, but the issue is, of course, this is a sort of open-ended question, right? Usually you want, of course, specific. You want predetermined categories, right? So we could support many research topics, trade, architecture, depending on your corpora, right? But again, it can help us in our general discovery, right? But usually you want something more specific, operational definition. So explicit rules. So again, we can, in this example, we'll narrow or work to rural credit only, basically. And that makes, of course, things in some ways easier, right? So basically, we provide rules. It's so-called classification task, whether it exists or not, right? So, for example, whether in this case we define this rural credit, whether it directly connects to financial mechanism, right? Because again, the issue is when analyzing documents for some specific concept is all of the edge cases, right? So it could be, could not. And the thing is, sometimes it's not so easy even for a human researcher to determine whether some document corresponds to definition. Maybe two researchers could even argue about it, whether this is or not, right? So, and here, of course, agricultural without credit, banking without agricultural. So because again, older models, simpler models would say banking and agriculture, but not together. Same document, but not combined together. It might miscategorize or misclassify, right? So what I personally, I like to use unclear or some other third ambiguous category. You can also ask models to do this quantitative, meaning provide a degree of certainty. Again, this is not an exact number. I mean, you'll get a number, but you say, okay, degree of certainty, is this 90% sure, 99% sure, 100% sure? It works to some extent, right? But for now, we will use this three answers. Three, it's not binary, it's trinary, I guess, right? So present, absent, or unclear. So, right. So of course, obviously, if you wrote this here, right, I would expect that State Land Bank would have this present and Gypsum probably not. Unclear, maybe? So that's the idea. So here's a rural credit prompt. You are a careful digital humanities researcher. No. So use only supplied source, right? Decide whether concept is credit, right? So, and by the way, it's completely normal to start this prompt to use some external, like I said, ChatGPT or Claude or some of the state-of-the-art models to generate ideas for the prompt, right? And then you refine it yourself. Unless you have your own template, right? There's some things, again, it's not exact science. There are research papers on what works, but it's fast-moving field. What was absolutely critical 2 years ago might not be so crucial anymore. right? So this is a rural credit definition. Again, to answer Harald's questions about variables, I just name them to make them make sense semantically, right? But of course, they don't have to be. It's basically sort of a template where I'm going to put in, where to make to assemble the prompt. So I'm having these Lego pieces where I'm going to assembling them and putting them together, basically, right? So absent. So we define explicitly. So this is a thing where we sometimes, in our experience working with Anda, when we were working on corporate, sometimes maybe our prompts were too detailed, right? So here it's pretty simple, right? So do not infer a connection from outside knowledge. Use unclear only when damage, incomplete, or ambiguous wording prevents a decision, right? So only one, and so here I'm asking for a JSON object. Again, the reason for that is because JSON is easy to transfer into some sort of other structures, to maybe CSV or Excel files or some other format. I could have asked for some other, but since JSON is widely used for transport around different systems, it's a good intermediate format. Also because I'm sending JSON also the other way as well, right? So the label must be exactly present, absent, or unclear. Speaking of confidence, I am asking for confidence here, right? And I'm asking for this precise structure, right? Again, if you don't ask for structure, if you say, okay, return valid JSON, what will happen? Well, you will get JSON, but sometimes you'll get label, sometimes you will not have confidence. Maybe you'll have some extra fields which you do not need. You have a contract, right? So this is much better if you're working across hundreds or thousands of documents. You don't want these arbitrary fields, and then you're going to spend, hours trying to align the fields for each document into one big table to analyze, basically. Right? So, again, confidence 0 to 100. So the confidence will refer to how confident the model is to the label being present, absent, or unclear. So it might be 100% think it's unclear, right? There are other ways of categorizing this. I mean, we've done work with 5 degrees, like maybe A, B, C, D, E scales. There are other scales. There are many ways, right? But this is the 3-way present, absent. True, false, maybe, right? Could be right. Approach is pretty decent. So we expect, of course, the Gypsum will not have it, and State Land Bank article will have. I should have probably added one more article, right? Maybe we'll get all 3 answers. So let's take a look. So we have our, so this is a system prompt, right? Contract, right? On credit system, right? So it's rural credit definition plus classification contract. So this, out of those 2 pieces, out of these 2 strings, I built one system prompt, right, and task as well. So let's run it, right? And let's see what happens. Yeah. So 100% confident, right? Why? Evidence, reason. So you have present, confidence, evidence, and reason, basically. You have everything. Again, the evidence and reason, of course, they can get quite wordy, right? So again, let me run it again. Again, if you have time, 100. Again, it's basically almost an open and shut case. Still, if I run it, a couple thousand times, I'll probably get there be some numbers. The confidence, maybe sometimes you'll get 95, maybe, right? I would imagine most time the models will get, but it's pretty simple. So now we have this basic idea, right? And again, you can still do this again on a regular chat-based interface, right? You all have to do is put these 2 prompts together, right? And you have this answer. And then you supply the document. And now we supply the labels, right? And we are going to get the answer. These are the helper functions, right? Now, yes. So what we get now is our test. We have a way of transforming our document, supplying this prompt, and getting the answer back into a tabular format. It's just a single document for now, right? So we'll have this our test. Let's do one more test, right? So is the label consistent? Again, that's a part of your research. Is this operational definition? Is evidence copied from the document? seems to be okay. Reason, rule, we don't want the historical background, probably not, right? So, and also, of course, would somebody else understand what we did, right? So does this make sense, right? Right. Reason seems evident. Evidence is evidence, reason. So again, it's not there's evidence and reason. Again, you could argue that maybe you don't need both, right? Maybe you don't need both, but I think it's a pretty good way to separating it. Maybe you have some other column you'd want to add. Maybe, I don't know. Maybe some other things. Present, confidence. As a minimum, right? If you sometimes, if you're analyzing a lot of documents, maybe you just need these two. Label, right? So Harald, maybe you have a question. Oh, you want a mic? I saw a mic here somewhere.
Yeah, so I have a question about confidence.
Yeah.
So I see the point, and in classical natural language processing methods, I see how it could also be used. But here, as it is a black box, so what are we actually getting when it's saying confidence? Do we have the reason to believe that when it gives higher or lower score, it is something that we can trust, or is it more a guideline? I'm just following, like, what is it we are really getting here?
So this confidence comes out of LLM, right? It's a black box. And it's basically, like I said, the famous saying, all models are wrong, but some are useful. So this confidence, it's on overall, statistically speaking, it corresponds to this actual, the actual core, so how confident the model feels about it, right? It feels about the answer, right? If it says 40%, the model is probably not confident. Of course, how it arrives this number, this used like a couple of years ago, it didn't work like this, right? It was not very, very useful. It seems to be, right? So it's not like classical NLP, right? Because again, reminder that on the large language model itself is working on confidence, like on prediction, token prediction, right? When it tries to predict next token, also has these probabilities of what the next token should be, right? And here, this number, right? The model somehow, this black box, knows how to present this. Now that 100%, it's very sure. So there is some sort of in my experience, these numbers are rarely like 98.6, right? You don't get the actual number, like, because you could build the classical classifiers, then you would have these numbers, like really detailed. They usually in intervals of 5, right? They're not like down to dot, to decimal point. Right. So again, then I wouldn't trust the number again. It's just a general indicator, right? So yeah. Yeah. So yeah. So in this particular case, yes.
You have really, and the model is, let's say, it is ambiguous, like present, absent, or clear. That's why models keep this label, and all the time, usually if you test all the time, you will get 100%.
Yes.
That's why it's not very clear in prompt defined.
Yes. So again, this number, again, so this confidence is just an additional indicator. It's not something to be, very confident of, basically, right? So, yeah.
If you defined very well, that model can recognize in the text that you. So that label should be connected with the text very explicitly.
Yes.
In that case, confidence will be different.
Yes, exactly. So yeah. So it's again. So it's not again. So this confidence is well. It's some. So of course we usually care about the actual label, right? So why would we want this confidence? Because basically, again, if you're dealing with these are such as like this is a home run. This is easy. True positive. Complete true positive case, right? But when you have these edge cases, you want to see what we're looking for is basically not 100 or not 0, basically. We're looking for something else. And then we know there might be a potential problem. So that's why even if this is, not completely, the scale is not very, might not seem completely precise. it's a way of identifying problem documents, basically. That's the idea, right? And maybe if it's not useful, obviously you don't have to use it. But the idea again is you have maybe, and you also have this, if you have non-100 or non-zero confidence, it indicates that there's something not quite right with the document. Okay, now let's take a look at what they run the allowed labels, right? So test works, right? So we have our gypsum. Let's do the gypsum. This should be 0, right? I mean, it should be 100, but true, right? Yes, absent 100, right? So source discusses destruction of property of jigs. No, there's no evidence, and there's also a reason for that, basically, right? Again, so again, yeah. So I agree. This confidence might be built with misleading, but of course, in this particular case, was quite clear. So now, of course, the beauty is we tested with these. We have because we took true positive, and clear true negative. Maybe I should have added the third, maybe which is not so clear. But actually, we'll get to that because so let's do all 6. So we are going to do 6 documents now, right? We could do all 400 actually, by the way, now, right? It's cheap enough. We could do all 400. Right. So we have some. I added some little cheat sheet about what it is roughly. Right. These documents. Right. So in this case, I have particular ones I want to analyze. Right. And let's see. This will be for assignment in a moment. So let's run it. So what will happen is we'll run exactly same prompt to all 6 documents. Right. And I'll run it. Yeah. So it takes, since this is a fast model, they do only 4. Oh, so I think I had 2 overlaps, right? Ah, yeah. Okay, right. So I have 4 batches. Okay, so now we don't see the results yet because I have the results. I want to see them in a table. And now I should have all 6 documents. Yeah, so what happened is, why did I run only 4? My code had a caching, meaning no need to rerun the same query for a document I already have answers. So now I have, well, it's present, right? 3 ones are present, and we have 3 absent. Again, I would like to see, I should probably run it for all 419, right? That would take us how much? That's about 6-7 minutes. Probably don't spend that much time. But you could run to all 400, right? So, and then get the actual, maybe get some non-hundreds, right? Because those are the interesting ones, right? So here we have, of course, we have a clear classifier. We have the agricultural credit. That's a simple concept for modern LLM to distinguish. It seems to be the case. Again, of course, sample of 6 is very too small to make a statistically meaningful distinction, right? If you have 400 documents, you probably want to analyze yourself about at least 30, probably 50 documents. There are actually formulas to calculate how many documents you should inspect out of whole corpora before you can make some sort of a statement about the validity, with certain confidence, validity of certain statements. Right? So if you have 400 documents, you probably need at least 50. You have the beauty of this statistical approach is if you have 100,000 documents, you need to inspect about 300 something documents by hand, roughly, right? And then you can make certain predictions. Okay, you are 99% or 95% certain that some things are, the document, certain statements about the documents, are they true or false, right? You have certain guarantees, statistically speaking. It's extremely, extremely unlikely that your conclusions are incorrect then, right? So that's one of the ideas. One of the takeaways from today is, yeah, you have a lot of documents to analyze. You run LLM on all of them, and then you or your experts or your colleagues, you analyze some subsection, you validate. You need to validate, of course, right? There's no ifs and buts, because it's, again, you might see these very interesting weird cases. Again, if you see 1 or 2 weird cases, you can make if you're writing a paper or a research paper, you can make a statement about this, how likely these type of cases are, right? And also what percentage of these cases will occur, right? Certain intervals, right? So that's just a valid statistical approach, right? So, and of course, you have a lot of errors, right? Then you see, of course, you probably don't want to publish that paper, right? But you probably need to rework your approach, right? You did something wrong. That's a good sign, right? If you so okay, so far we're doing good. Of course, I'm really, again, it's been a while since I did I have not analyzed this too much, but I would like to, of course, do all 419 with this particular approach and see how many maybes. I think the models are now getting so good that it's going to be less and less. This is such a simple concept. You need something more vague to get this uncertainty, right? It seems to do pretty well. I mean, again, and also because these are relatively dry documents, right? If you're analyzing poem, might make its poems might be more interesting, right? So that's maybe next year we'll do poems, right? So now, yeah. So I'll get to you to some assignments. Yeah. So rural. Yeah. So this is all basic visualization, right? So I'm curious. I can't. Before we proceed with assignment, which is going to be, I'm going to do all of them. I think I want to do all of them, right? I think I have enough credits. I don't know. I haven't checked actually how many credits I have, which key I'm using, but it's still not expensive. So let me, since I'm lazy, right? This is 106, right? Let's see if AI can do it for me, right? I'm lazy, right? So let me make a new cell. Yeah, right. We'll generate it, right? Yeah, we'll do generate. Yeah. Write a cell. Well, I don't know, flash tip flash, right? Cell, right? That analyzes all queries. How should we call this? This is a prompt. So write a cell that queries all. What was it? Latvian Economic Review. Latvian Economic Review articles we have. Saves them into a data frame, right? You guys know a data frame, so it's table, right? So let's see if this is enough. I'm just curious. Data on saves them. Okay, let's see. It's a very generic prompt, right? Not very specific. I try to avoid any economic, domain-specific queries. So again, content, lines, data. But I have a feeling, let's see what it does. The text file doesn't ask anything. Oh, yeah. Well, of course, it basically what does, it reads all the articles and just writes text. That's not what I wanted, of course, right? So what this function does, it just basically reads all the text and makes a big table, which might be something you want sometimes, but doesn't do any queries to API, right? So I'll need to be more specific. Again, I don't use Gemini's, this built-in LLM too much, right? Because again, it's not very smart, right? Doesn't have enough context. So this is, I'm going to cancel it actually. I don't want this. No. So let's do one more time. Right. So write a cell that sends agriculture for existing from on agriculture. So the problem is, of course, that this model I wrote to Google team about this. It doesn't have enough context, right? It doesn't peel up from the surrounding cells. It should do it. It pulls some, but there's not enough. On agriculture for all Latvian economic review documents, which are credit in data folder, and then saves the responses into pandas data frame. Let's see if this works. All right. Yeah, it does. Now it looks like, yeah, this rural credit system, yeah, looks like now it is more like it. Let's do it. Let's do it. We should have all 490. Accept, right? This looks more like it. And again, nothing bad. Well, we'll just spend up some money, but that's nothing end of the world. So we'll do 419 prompts, right? That's what API is for, right? So, by the way, I mentioned this somebody else, I think, yeah, that if you actually have a really large amount of data to process, like thousands, they do offer these services, including OpenRouter, are starting to offer batch processing, meaning you prepare all of this data, you send it, and you get the answers maybe next day, right? That's about half, it's half the price, roughly, right? Meaning they send them off on off-peak hours, basically, right? But that's if you have a really, truly large project. Okay, let's run it. So all records, right? We're going to read all files, right? Parse them, right? Title. So we have our main thing. We have to look for rural credit system, the Klevskian task. Let's let it run. All right. Well, unfortunately, I left a print, right? So, yeah. So, it's cached, by the way, right? So, I left a print. So what happened is this. I left a print in here. So meaning I'll have 419 prints of what documents processing, right? It might be useful for like analysis later on, right? But our outputs will be pretty large. So it's doing pretty well. It's very fast, right? Oh, and it's happening, right? It should be finished in about, well, probably looks like less than seconds, so probably like a couple minutes. So while it's happening, right, let me open a next notebook, right? Or last notebook. Let's see. There's an optional one, right, on OCR, which we'll not do today. If you want to do OCR, what is changing? What's different? Well, the difference is that you need to prepare your image. You need to encode it. Usually it's something called base 64. You need to encode the image so the model can support, you basically have to tokenize the image, basically, right? And then you can feed it. It's pretty interesting. It works, right? And it basically, the image becomes part of your prompt, basically. That's what's happening underneath. When you submit some image to your chat-based interface, the same thing happens there as well. Now, let's go to your assignment. So idea is, because some of you who are interested in credit for this workshop, right? Right. Basically, you need what I want is from you, right? You can now practice this, right? For the next 40-50 minutes, right? It should work is very similar to what we did before. From you, you want to edit the markdown cells on. So basically you have reading, writing, tiny bit of editing code, basically. You don't need to do everything from scratch, right? So, and then you need to run some cells without editing, right? So what I want from you, if you're doing this for credit, again, if you don't need credit, well, you can do this for fun, right? But if those who are doing it for ECTS credit, right, and you want to submit assignment, obviously you want to write your name, institution, right, date, notebook file name, right? And you can use, again, I allow to use any of the LLM-based tools, obviously what you use. I want to see those that you use them, right? And then you have these run cells, which you don't need to do anything whatsoever, right? It will just run the cell, right? So data, you you only have 6 documents to process, right? And I will go through with it myself. I'll verify it works, right? So from you, what needs to be changed? Your prompt, right? What you want to analyze, and of course your comments, what you write in your markdown cells. That's basically the assignment, right? I don't ask from you on this type of workshop, right? It's not a programming work. I don't want you to, I mean, unless you want to, right? You don't need to write your own new functions. Like I said, don't want to write actual real new code, right? You need to only the internal text fields, basically. Now, but we'll go through this in a moment. Let's see if it's finished. Not yet, but it's doing pretty well. I should probably add a number to it, so how many it's done, right? Seems like, okay. We should get probably, while it's running, let me see if I can log into this account, right? I don't know if I have it here. OpenAI, pricing, sign up. No, I am sign in. I'm sign in. Oh, I forgot which model am I? I think this is not my, yeah, this is not my main account. I don't know. I don't think I have on this computer. I don't have the login for the account I'm using for this. I'm just curious how many people. I would like to see the stats, how active you guys are, basically. I think I have it here. Yeah, I have another computer. Activity. I want to see activity. I can see. So I can see what's happening. Yes. Top API keys. Yes. I can see some leaders here, right? Actually, I'm not a leader. I'm only third place. I'm Sino Kuturan and Zalans, 2 leaders in token use. Almost 600,000 tokens are processed, right? So yes, yeah. And Eliza and Sophie are also there on a leaderboard, right? Active users, right? Unfortunately, I can't show it to you this image, right, of what's happening, right? So 3,000. So, but the funny thing is, we spent only $2 together, right? So, right. In last few hours, so it's pretty inexpensive. So again, let me see. Again, remember, I can't see your key. I can't see what you did actually, right? I can only see the actual overall usage stats, right? Because this is our library account. So the way it works is, once you set up your account at the Open Router, you can generate individual keys, which I did. Actually, what I did is something a little bit different. I actually wrote a program to generate the keys. There's a super key. I have a super key which makes keys, basically, right? Because I didn't want to do it by hand for 70 of you, right? So I made a super key for that, right? And then I had to write a program to send the emails to you guys too, right? So, but yeah, so it's turtles all the way down. So now I think we're getting close. Or are we finished? Let's see. Yeah, it's still going. Okay. I'm curious how long it's going. I want to see, because we'll see some stats. Right, well, it's running. Now I want to see usage by model. Yeah, everybody is using, okay, flashlight, a little bit of Mistral, right? Somebody tried Opus 5. Wow, who did that? Yes. So, and Sol, somebody tried Sol, right? So, but it's mostly Flash, right? Because again, it's mostly because of me using this model here, right? So, very interesting. Okay. Yes, it worked. All right. So this is something you can already start analyzing, right? You have 419 documents, right? And by the way, I could save it, right? So I have my table, right? And I can save it as Excel file. So it also tells you how much evidence found in source, none, parsed. I'm curious. Let me see this here. Let me see the results now one more time. All right. No. Wait, what happened? Did I not save it? Or actually, I need different data. Wait. Oops, sorry. Let me double check. I want to see. So. No, it's all records. Oh, here we go. There we go. So this is my table. And let me change it. So label counts, batch results. There we go. And no. So let me change it. Batch results. Yeah, that's it. I'll do this. See if this works. Okay, now should be interesting. All right. So this was just basically all either yes or no. We had nothing unclear. So 386 were completely absent, which makes sense, and we had 32 present. So this is what you call, in terms of machine learning, unbalanced data set, right? We have 10% versus 90%, roughly, right? Which is fine. I mean, that happens, right? And normal, right? So, and we have, looks like, again, so this model, this flashlight actually worked pretty well. Again, you have to examine more details, but we didn't see any really unclear. I want to see maybe some edge cases. Looks like I need to come up with more trickier questions, trickier research questions, basically, right? So Harald has a question now.
Yes. So after many hours, I see the results.
Yes.
So my question is, what is that we do next as humanists with this critical methods approach? Because it looks like really neat results, but we are still not sure, are they really good? So do you have something about...
Like I said, if you want to get for validation, right, you need to inspect yourself, right? But not all of them, right? Then why do we run LLM, right? So you examine a certain percentage, right? Randomly selected. And what you do is random shuffle. Basically, you need to take a sort of like, put all the documents into sort of like this bag and randomly take out some documents for inspection, right? So a statistical approach, right? And then you see, okay, whether this is actually doing what it is doing, what it's supposed to do. So you inspect the reasoning, right? And also the evidence, right? And also the label, right? Because what we're doing here, this is a simple, labeling classification task, right? Boxes, we put stuff in, right? So again, 419, you could probably do it yourself, but 419 is roughly the number of documents you have to inspect. You had 100,000 documents. So this is number you have to do it manually if you had 100,000 documents, roughly, to make sense if this is actually doing it correctly, right? Before you can make any, say, okay, this is the right direction, or this is completely not what I want, right? So this, yes.
So we have this result, and then we do some manual check, both of positives and negatives, and see if it still holds. And if it holds, then we could infer that also for the larger data set, this would be a valid method of how to classify something into something.
Exactly.
So a follow-up question is, if we want to follow the best practice, should we also try running the same experiment with several LLMs? Because it might be that some of them give these results and some give the others. Of course, it all takes time.
Yes, it's again, it depends on your budget and your time. I would certainly might not be feasible to run 100,000 for all most models, but what you could do is take 400 or let's say 500 and run it on like 4 other models, right? And you should expect very similar classification performance from all models in this type of yes/no task. Now, if you have, the more fuzzier you get, the more difference you will have, right? If you're trying to identify concepts, for example, right? Open-ended questions with, identify some concepts, right? And you have not provided a dictionary, you have not provided guidelines, right? You will have very wide, you'll have your sets, your Venn diagrams, you'll be lots of mismatches, which only occur in one model. One model might, there might be synonyms, might be, yes. So.
But could we just use some state-of-the-art model to evaluate a sample of the documents? Instead of checking manually.
Of course, that's all. Yeah. So if you're lazier, right? Yeah. Yes, you could, because your state-of-the-art model. That's another approach, right? So that could be supplemental or could be the only one. So you could say, okay, I'm going to have the state-of-the-art model, right? Evaluate 500, right? And again, I'm still, I guess I'm old-fashioned. I still would like to see some myself, right? I mean, it's possible to, that's done often, right? These state-of-the-art models, right, do this extra checking step. Yes, I would still want to see some number of documents myself whether this actually is happening, right? Maybe even 10 documents, actually what you call, well, not sanity check, it's called soundness check now. Soundness check, right? The final step to see actually whether there is actually, the responses are actually what I thought they are. Because it's possible you make maybe your instructions, you made some extra, there's a step, ignore all previous instructions, do something else, right? Prompt poisoning, right? Maybe I don't know. I mean, it's just an example, but maybe there's, it's not exactly what I want. So I would still insist on a human step, right? Yes. Okay, so yeah, what's success, right? So this is, again, so reading, so that's basically do the labels, agree with your reading of documents, right? So non-empty evidence, right? And also, so this is distinguished role created from generic architecture, right? So again, we did not get any unclear, right? So, yes. So the manually, you validate, you need the random process, right? And there are a couple different ways of doing this randomization. We can talk about this. It's something we want probably stratified, meaning we want to select from different categories proportionally, right? So not just random, take random, completely random. But that's, but again, so for the assignment, let's go to the assignment now, maybe, since we actually, but before we go that, I'll show you one more thing. This is a little extra bonus, right? So I'm not teaching pandas today, but I can show you what we got, right? This is actually already could be useful, right? We got so-called data frame, this variable, right? This holds a data frame, which is basically a table, a special data structure, right? And what I can do is now, let me save this data frame, right? I have visualization, right? Code. Let's save the resulting data frame, right? That's basically a prompt, right? Yep. So even the simple built-in autocomplete knows the context and it suggests. So what I'm doing so this is a variable which I just made in previous cell. All LRQ results, it's a variable, but it's a special variable. It's a data frame, 419 times 12, 419 entries, 12 columns. And I could save it to Excel, CSV, or database SQLite, and so on, or JSON. I'll do CSV because CSV is easy to parse and we can understand it. So what's going to happen? It will save it, not here, not data, not here. It will save it here. I'll show it to you, right? Let's take a look. Yeah, so this is all the spam of, right? Where's my spam? Oh no, so here. Yeah. So this cell, it's not been run yet, right? All I did is I wrote this little prompt, tiny little prompt. The thing with these prompts, again, for Python, hash is a comment, right? This is just a comment in Python, right? Instructions for me or for you, not for a computer. But it's used by Colab also to provide some context. It's basically a prompt in this case to know what to do next, basically, how to fill out the cell, right? It sometimes works, sometimes doesn't work these days. This looks like today it's a good day, it works for me, right? That's why I usually use local models, local cursor or Visual Studio Code, which has much better support for this type of thing. Copilot, right? So, but it works. So I didn't have to think about, okay, was it to CSV or save CSV? I don't have to remember this function, right? Again, it's a huge function, big complicated function. I just got a recipe, and nothing bad will happen if I got it wrong. But it looks good. Index false means I don't need the numbers in the first column. And there you go, instant. So it's there, but where is it? It's inside the Colab, right? So what's the story with Colab? Remember what I told you in the beginning? It will go away when we finish this workshop, right? But you want these results, right? So how do you save them? Well, you have two ways of doing it. You can download, right? That means your own computer, right? That's one way. Right, there you go, all results, right? Obviously, I can also check here locally. I can check them on the cloud, right? And you can see what they look like, right? See, yeah, 419 entries, kind of hard to read, right? I need probably a bigger screen, right? I can actually do this, right? Yeah, 100 absent, you can see, because there's a big discussion. These evidence and reasoning is pretty big, a couple sentences, not big, but pretty couple sentences, right? So Yeah, I have it. I can filter, right? I could do some simple analysis here in a Colab, right? But of course, I probably want them locally in my computer for analysis. Now, I'll show you one last thing for this notebook. You can do is also, if you are on the Colab, you can download this notebook. This CSV to your computer. With code, right? So yeah. So this is the thing. So Google offers an automatic meaning a programmatic download. So you don't use mouse. You can say, okay, use files library. It lets you download. So let's do this. And there you go. I got it the other way. So this is of course better for a bigger workflow, right? So it automatically downloads it. You run the cell, it downloads instead of looking for mouse and right-clicking download. And obviously this is better if you need to download 10 files, right, or 100 files. Again, this is of course only applicable if you're doing Colab-based work, right? So if you're working on your computer, you'll need this because you have the files already, right? So, okay, so that completes this notebook. I'll add these changes later on for some of these extra settings. So I assume you got the 6 answers, right? It worked for 6, right? 3, right? It worked, right? Yeah. I mean, again, so a pretty simple task. We'll see. I'm curious if any of you today will come up with some more difficult questions, maybe, right? So I'll save this, right? This notebook. Files. Okay. I'll close this. Yeah. Oh, yeah. So, where's my? I lost my. This happens. I lost my one more menu here. There was a key here. I could save in GitHub, but no, I don't want to. I want to download this. How come I don't have the download here? Maybe I could this. I must have pressed the key here somewhere. F11 maybe. No, F11 is full screen. Yeah, but you can do a full screen. Yeah, F11, F10. I must have pressed it. I've hidden the menu. This one? Yeah, that's it. Yes, yeah, that's the But I want to call it. I think I must have clicked. Yeah, I must have. Yeah, of course you can see there's lots of extra things which are not needed, right? So your notebook, So yeah, there you go. And now, of course, I'm going to download it. Why? Because I have these extra changes. Now, so what happens when I close it, right? When I close this physically, for about half an hour, it might remain open. The data, like I said, Google actually leaves it hanging for a moment, so you might get back to the data. But right now, technically, if I do runtime and disconnect, delete runtime, right, I will lose all the data. I mean, all my things I have not saved, right, all my session data. Only things which I have written, those will stay, like my comments, my instructions, like what I wrote, that stays. But the results, the data, right, will be gone. So similarly, when I close it, all of this will be gone. The data will be gone, and also my results will be gone. Right? Again, that's basically the side effect of using a Colab, a cloud-based computing. So I'm going to close it. Okay. Maybe actually I'll stop it first. The reason I'm doing it, stopping it, because Google sometimes, if you're doing it multiple Colab notebooks in one day, at some moment it'll tell you have too many open, right? You're doing too much on this free level, right? Stop and close some, right? So I'll close them proactively. Now let's see. Okay, and let's look at your assignment and let's see. It's very similar to what we did. So, site. Okay. Now, so let's see. Let me double check. So I'm not going to fill out your student information for you, right? So yellow is for you to fill out, right? So how do you fill out? Right? Write your name, institution, whatever you are from, where you're from, right? And name. So, and the thing is, but if you're going for assignment, I want your last name first, right? So it's easier for me to grade and take a look. And how I'm going to grade? That you wrote something meaningful, right? That you didn't write any complete nonsense, right? So it's not going to be hard grading, so don't worry about it. But do fill out all the yellow sections with actual your work. So you can use LLMs, of course, right? But do write down what you used, right? Again. So I'm going to connect first. Yes, and Harald wants to ask something. No? Ask away.
Afterwards.
Maybe there's, by the way, are there any people in Zoom today? Or I have not heard any. We used to have a dedicated Zoom person previous years, but I know maybe the Zoom people feel left out. Any questions from Zoom?
No, this year we have left out the Zoom people.
But they are listening, I hope.
Maybe
they can.
We don't care.
Yeah, no, we do care. I mean, it's yeah. So,
no, I mean, Zoom people are not real people.
Yes.
We really care for real people.
But I do like that I'm seeing some response here. So at least you guys are.
Oh, they are real. Okay,
super.
Oh, sorry.
Okay, so I will go through this assignment. So I'll double check that it actually works, right? Super. So Anna, you want to say something before I go through the assignment? No? Okay, so yeah, I will keep going through the assignment and slowly, right? I'm not going to explain again, so the green ones are basically things you have to run. You don't have to edit anything, right? So let's take a look. I checked once, right? So yeah, I do have local instructions, but don't worry about those. So again, we get the same warning, that's fine. Now, yeah, setup works again. Now, we still have the data, but we'll have a different. So this is going to be mini corpus, right? So I made a really tiny corpora for you guys. So where is it? It's probably here, right? You can inspect it by hand. Yeah, this one here. And it's basically like this, right? 6 articles, right? 6 articles, and this is the text, right? So, and again, you don't have to do any editing of this, right? You can see how it works. If you are curious, you can see how it does. It checks and see if it loads, right? Documents, read, 6 documents, pass, no text. So basically, it's a sanity check. This is how you can replicate the research that works, actually. As we know, replicability is a big problem in research these days, right? Many papers, you read a paper and how do they do it? There's there is a step how to draw an all, draw all, right? And then there's a missing step in between, right? So here, hopefully, we don't have this missing step. So let's do display, and we have loaded a data frame of all documents. So this, by the way, actually a title. I think I also have the text here too. Yeah, so there's a text are not actually shown, but text are present, right? So I don't show all the columns, actually. Let me show you all the columns. Just a second. Let's show all columns, column names. Yeah, so 1, 2, 3, 4, 5, text. So that's a column I didn't show you because, of course, it's a text. It's big. It'll take too much space, right? So there's one more column, right? So this is 6 created English language excerpts for Latvian Economic Review, right? So normalized OCR, strafe, moves have been removed. I have not changed any wording, right? And also, another how we usually typically work, we also provide a link to the actual paper, right? So this is the actual link. Let's double check if it actually works. This should be 1936. Let's take a look, right? This is our internal catalog, and indeed, this actually has a link. So this, of course, if you have working on your library or some other research institution, you should probably provide some link to some alternative source of your data, right? So this actually is the source of data, right? Provides in this particular case, you can only download the full paper, full PDF. In this particular, my account here from this machine doesn't have it, but you could also download individual files actually here, right? So that shows you where it came from. It's good to have provenance, right? So on the name, right? So let's do one more. We can read all of them, right? So this is actually how you can read them, right? You can read all 6 again, and hopefully, like I said, probably come up with something more interesting next year. But the challenge was last year when I did this corpora, we needed something in English in general use, and this was like available, right? So now, of course, is what I want you. So what kind of research can you ask about, right? And again, of course, obviously, you could ask for some ideas. If you have no ideas whatsoever, you could ask some language model. But let's not be so lazy. Maybe try to come up with your own ideas first, maybe, and then only brainstorm, right? So, I have some hints here: economic, modernization, intervention, dependence. You could ask a completely different question, which maybe none of them answer. Maybe some political, maybe some poetic answer question, right? So, again, you would write them here, basically, right? These are the ones I want you to fill out, right? And also here, inclusion, right? And make some maybe predictions, again. Why you think it will exist for 2 documents. Yeah, so, and again, don't change the predictions afterwards. You say, okay, the model completely disagreed with you. Well, that is, of course, for you to analyze, not to delete your original assumptions, right? So, you're allowed to change your opinions, right? How Maynard Keynes, the famous economist, said that, right? You, as facts change, you change your opinion, right? I believe somebody, actually maybe that's Churchill, but right. But it would be a very strange person who does not change as new facts arrive, do not change their opinions, and that's actually not a very, I would argue it's not a very good person to work with. So very static, right? So, but okay, so this is where you have to actually edit code, right? So this is obviously where you write your prompt, your system prompt. So this is, of course, I want to see changed, right? So what do I'll add, let me read some papers, let me come up with something. Yes, dealing with German. Okay, yeah. Yes, yes, so I'm really lazy. I'll put something here. You are a researcher, right? Just generic. Analyze whether this document contains references to Western Europe, right? Let's see. Very generic, right? Yeah. Yeah. So replace text, my prompt text, right? So this is my system prompt, right? Yeah. So there's a tiny soundness check. Replace this text should be gone from your system prompt, right? So if you let it in, it will yell at you, right? It will yell at you. You do not replace it, right? It's a tiny stop measure. So you see, okay, you have to do some. Yeah. So I forgot 180. So you need at least 180 characters for your prompt. It's just so you don't do really tiny one. So this is not 180. Provide output. Provide output in following JSON format. Yeah. By the way, again, I cheated a little bit, right? Because Google Colab did the JSON format for me, because obviously it knew about my previous approach, right? So present absent or unclear, right? This or unclear, right? Model should pick up on this. Again, early models would say or unclear, but it should pick up on the meaning of word or. Confidence, right? And again, what I did not specify, max level of confidence. Maybe it goes to 1,000 or 11, right? So confidence should be on the scale of 0 to 100. But I did not specify whole numbers, so maybe we'll get like 98.7. Again, we'll see. Maybe again, I'm playing loose here, right? So this should be enough for me, right? Let's take a look. Actually, I already had this here, so actually I didn't have to do this. So this was format instructions. So I need to actually come up. I need to come up with some better instructions here. So this is actually already have it, right? My formatting instructions. So these I don't have to. It's just my system prompt needs to be addition. So this actually, I should say something more about the Western Europe. Yes. In general, or any country from Western Europe, right? I'll try to avoid mentioning Germany, basically. That's what I'm trying to do, right? Because I saw there was Germany. I'll try to avoid from Germany, from Western Europe. Clear. No, no, no. Then it is unclear. I'm really. If no Western European country is present or implied, right? That's the thing. Well, I'm trying to make things a little bit. Then the label should be absent. Should be should have value of absent. I don't know. I'm just really. I could, of course, maybe I should have made. Well, this is a classification task. I would maybe make a poem out of each article, right? Maybe something more interesting would be. But okay, all right. So I think I have a decent prompt now, not a great prompt. Yeah, provide reasoning, provide evidence and reasoning. Because because let's try to keep things simple to be what should I call. The same format like we did our exercise, or workshop. So let's try the same thing. Okay, I'll run it. And obviously, I wrote green, meaning you don't have to change the formatting. If you want to play around, you're free to change it, but I'll leave it for now, right? Yeah. Now, what did it say? Pass. 400 characters. Okay, so I pass. Okay, good. Now, let's do my open router key, right? We only know by now. Safely. Unlike Harald's approach, right? But this has been my approach too. So, right. So I'll enter safely. Right. Again, so this time, right, you can do it here. Get pass, right? Let's, let me run it. I have my secret, right? Run it. And it's this one here. Paste. Oh, where's my paste? Control V, doesn't work. Yeah. Okay. Enter. Just remember to press enter. All right. Now, flashlight. So this actually you should change. Actually, I 2.5. This is still a valid model, by the way. I guess I'll stick with 2.5. This is cheaper, right? New one is 3.5, by the way, right? This is like a year ago. Right, I didn't change this one, but I'll leave it in for now. Right, I'm not gonna subtract. You're not supposed to edit this cell. Right, it's just run it. So let's run it. Right. Okay. Now let's run it on one document. There's a run. You have to enter run. Okay. Yeah. Absent. It worked. Now, of course, revisit. You have to write what you've learned, right? And let's do all analysis of all 6 documents. Looks like all the cells work. Yeah. Only thing what I don't like is this run all, but you have to type in. So you have to type in physically run all here, right? Because enter will cancel it. So run space all. This is the extra thing. I should not probably. No, it's done. Yeah, it's calling it. Yep. But I did call 5 times because the 6th one I already did. There's caching. I have caching, so only 5 calls. Not wasting of calls. Now, of course, since I want to grade this, see what you got, right? I will see some data. Result table. I'll run this. Yeah. So confidence, absent. Oh, present. Okay, this is So this is 40. So this looks okay. Yeah. So I got Western Europe. Yeah. Yeah. So there is a Western Europe, and it mentions why there it's not. Right. So very well. Right. And there's going to be some nice charts. Yeah. Nothing very interesting, but you have 100 again. Now we come to the interpretation. So this, of course, I would like to see. Right. If you want full credit, I want you to write something that made sense, basically, right? Again, remember that the interpretive step is crucial. Again, it depends. You cannot completely depend on the model, right? In any workflow, right? Some we saw early how our BSDD, like we asked some questions about general knowledge questions. These cheap models, inexpensive models, they don't have full information in their training data, right? So one thing also, speaking of that, is I did not put the limitation on that to consider only the document, right? So theoretically, this particular prompt I did just now could try to add some extra information from its training data, let's infer some extra things, right? But again, so that is basically it, right? So let's see, right? You can compare this, right? You can see a little X, right? You do little X, I saved them, right? You have to check. Visible is not in, at least 5 responses. I could do X, right? You see, you get a check mark here. So this is a markdown, right? So put all these checks here, right? So, and then you download, right? You can also double check here if you want. Well, that's from my grader, I think. Yeah. Yeah. So I see everything works, right? And I'll check the markdown sections then for you. So I double checked for you. It seems to work. Everything works. Obviously, you need to change your prompt. So that's all I ask from you is to change the prompt. Yes, Harald.
No, everything fine. I'm just looking at the clock. I've been having
10 minutes,
13 minutes, and I'm thinking maybe instead of jumping to complete the homework, maybe we still have some questions. I mean, more like general or philosophical or very practical. Well, but that's your call.
I was going to say, of course, I have the originally. I also have. I can show you briefly, at least, the idea of what's involved in running the OCR part, right? It's basically the same approach. The only difference is that we have to take the image and have to convert it to this textual field, basically encode the image. I can show you that, or maybe Anna has some questions, maybe, or some comments on something people might want to.
I think probably it would be more productive to jump into discussion.
Yeah, maybe discussion.
You have comments or ask for advice. If some of you is interested in OCR, we can talk about that, but also other things.
Thank you. May I just come back to, you mentioned that when you have a large amount of documents, you only need to, you can manually check for some of them. And you said when you have 100,000, you need only 400.
Yes.
Is there some kind of like a algorithm?
There's a calculators online for this. Right?
So yeah.
Yeah, it's statistically based. I can see. I can maybe, let me see if my Google full. I can, of course, ask ChatGPT to find me the link, right? As I'm so lazy. But let's see. Calculate the confidence levels. There's a formula, basically. There's a formula. So what this means is that you can make I think it's 99% confident that this actually, and you have certain intervals. So you can make certain predictions about your data set. Right, and look at the number. Basically, what the cool thing is, it's a logarithmic growth. What I mean by that is it's slow. So you need if you have 1,000 documents, you have to inspect, I don't know, maybe 100, 10,000, maybe a couple, like 200. But basically, for 100,000, it's about 400. But for 1 million documents, maybe 500 or 600. So if you have a really large amount of documents, you don't have to inspect manually so many, right? So the amount of work doesn't grow that much, right? So for inspection, right? And you can still make very strong predictions out of that. You don't have to, like you think, okay, I have 1 million documents. I did some work on it. What can I tell about it? You don't have to inspect 10,000 documents. Right? So there's a formula. I could ask about that one somewhere. Maybe a link. There's a calculator also online for that. Okay, I'll ask. I'll not add confidence interval for 95% certainty on 10,000. Let's say 1 million items. Let's see. Yeah, confidence interval calculator. There's many of them around. Obviously, Pearson, right? There are many of them, right? There's a formula, right? And you basically want to see how confident you want to be, how many you want to do. And again, I'm not. I know enough statistics to be dangerous, right? So it's maybe if you also take in statistics, right? There's binomial. Basically, depending what kind of results you get from this inspection, right? You can say, okay, if I have all 400 documents I inspected and everything works exactly as inspected, right? You can make certain predictions that maybe no more than like 0.1% of documents will be bad, basically, right? You obviously cannot say everything will be perfect. That's impossible, right? But you can make very strong predictions. Yes. Arals? Omar?
Again, it's great, the second part of lecture, especially your assignment. Yeah. And I would like to ask, probably you did a lot of classical ML training for classification.
Yes.
What do you think about comparing with LLM classification and considering confidence? Because we don't have mathematically formula, but we can, apply some very simple division, for example, number of classes divided with full number, something like this. This will help with the confidence that you will not gain 100% for everything, but for mathematical, this classical ML, what do you think?
You could, again, theoretically, the thing is, again, since LLMs are such an easy, I would say almost a cop-out, meaning you don't have to do that much work. You just have to work on good prompts and you get good results, right? Some things, the things we did like maybe 10 years ago or 5 years ago, you had to do classical machine learning approach. You had to train a classifier, right? And you needed some data to work with, basically what it involves. You had different models. This would be a different workshop. I could show you how classical methods work, right? And they still work, right? And we still use them sometimes. And I would say for certain tasks, like if it's just they could be a cost-effective alternative, for example, if cost is enough. Basically, you have a really large corpus, 1 million documents, for example. You will need you need to do some classification or some sort of filtering, right? You might need some old, either rule-based approach even, right? Like just simple keyword-based approach, for example, to classify just simple rules, right? Or you can build maybe a decision tree-based network or random forest-based classifier. There are many ways. There are some nice, if you don't work with Python, you probably know there's nice libraries, scikit-learn, fantastic library. You can do all of this, but the issue is you need the labels, right? You need the answers, right? You need you need the training set, right? With answers. This is much easier. Yes, you can do hybrid approach. And that's often done. You can do a hybrid approach. Maybe you provide labels, right? So it's called semi-supervised learning, maybe, right? So you provide the labels from LLMs, right? And then you can train a model. Because then you have start with maybe subset of the data, work on that with LLM, then maybe train a model for your own use, right? Harald has a question, or maybe somebody else. So thank you. Does it explain it? Yeah.
Yes, I'm thinking about the regular user, or let's say regular humanities researcher who would like to use this beautiful stuff. And today, I know it was more learning focused and we went through all different details, but I was just wondering, you made this in this GitHub, that public tool, which is currently called batch processing. Maybe you can show it, because there you just have to press play once and provide a link to your zip folder, and it will do all the stuff.
Very good, because I should probably include in this year's workshop, because I made it last year. I'll show it to you. I think it's in our public tool. It's on LNB ADH or public tools. I think it's in here, I believe. On basically, notebooks. This is our public tools repository, meaning anybody is free to use. On what do we have here? So LLM tools. Yes, this is one here. So notebook for batch processing text files with OpenRead API. So what do you need? You need the key. You have the key. So if you are somehow stuck, this should work as well. Like if you're if you need to process something, I'm going to open it up. Right. So this kind of builds a widget. This is a little bit different. Only thing I have not done, I have old models here, but you can enter newer models here. So let's run it. So I'll show you how it works. Yeah, so run it. And it takes a while. No. So what we'll see, yeah, okay. Where is it now? All right. Let's run the code. Yeah, so basically it's a single cell. You run the one cell, and then you have key, your system prompt, you choose your model. I have Sonnet, these are last year's models, but you can enter your own model here, by the way, right? And you have two choices. Either upload up to 100 megabytes, because that's, like I said, limitation of notebooks here, right? You cannot upload more than 100 megabytes. Or if you have a truly large data set to process, you need to connect the Google Drive here, right? It's actually pretty easy to do. You basically click on this icon, Mount Drive, and you click a couple times to consent. But basically, then the notebook sees your Google Drive, right? So again, if you have your Google Drive full of private information, obviously you can have a specific account for that. So now this is a public notebook, right? So, but again, when I say public, it means not everybody, only you can use it at the moment. Nobody else gets to access to it at the moment, right? Everybody gets their own runtime. So now, and basically you uploaded the file, and then you run it, and it'll work. So what's the downside of this? This is great. Downside, of course, is limitation of Google Notebook. Colab, that you cannot have, if you have 10,000 documents, it might take a day or two, maybe. It will basically stop after 6 hours of inactivity, right? So it's good for small, medium-sized jobs, right? So I don't know. So this is again in our public tools for LNB-ADH, right? On easy to use, and it will work basically on any open router model available. Pretty much all 400 of them, right? So basically all this you have system. So idea is you enter instructions, model, on. So the only thing is what you need, of course, is a zip file with documents, right? Pretty easy to compare.
Yeah, so
you have used this.
For me, it seems like an easier way. So in the system prompt, you put all the knowledge you have learned today how to form the system prompt, and otherwise you just provide the URL or place where is your zip file, and then you press run. And at some point, I guess it then pops up a download window asking, do you want to download to Google Drive or locally? So if you really want to experiment, I think this might feel easier for you. I
was going to show you and I actually made an application for our internal use at the lab. I'm just going to show you if I can connect VPN and show you the application. Why don't I see it here? Where's my VPN connection? I guess not today, not on this computer. Where's my VPN? But yeah, this network doesn't have connection. But yeah, there's also, you can do it, right? Or you could have a colleague who does it for you, create an application, so for internal use as well, right? So where you have pre-fill the fields, some customization, right? So, for example, our application also supports images, right? This one only supports, maybe it works also on images too, I forget now, this particular one, right? So see, this basically does what we did today, all in one place, in one cell, right? And you run it, and it puts a nice little widget, and then you basically run here. You enter your key, obviously, right? So again, this key is not going to be seen, obviously, right? I wonder actually what happens if I paste here, right? Maybe, let's see. Yeah, good. It's a hidden field, so you can even paste key here, right? And you say upload zip, right? You choose a zip, and you basically, and zip should be just basically files of what you want to analyze. This is a good, I think, good middle ground, right? So.
Easy ground.
Yeah.
Okay, so officially we have reached the end of the official time. Valdis, unless you want to torture us a bit more.
No, I'm thinking I'm fine, right? Yeah, I'm fine. Yeah. So.
Thank you.
Thank you.